of food security through fortification, which highlighted how strategic policies and fortified foods can effectively tackle hidden hunger and nutrient deficiencies. Our final session of the day focused on public health and innovative foods, where we discussed how emerging food innovations can play a transformative role in improving nutritional outcomes and promoting sustainable diets. Those discussions set a perfect foundation for what lies ahead today. As we step into day 7, our session will take us deeper into futuristic and sustainable food technologies. Our first lecture of the day is titled Bioprinting as Food Fortification Technique. The session will give us fascinating insights into how 3D bioprinting is revolutionizing food production by allowing precise design and customization of food structure, nutrition, and even taste. Following that, we will have an engaging tutorial on classroom activities on 3D bioprinting of food and its critical appraisal, which will give us a practical understanding of this innovative technique. In the second half of the day, we will explore unlocking the power of millets and millet-based products key to food and nutritional security, emphasizing the immense potential of millets as climate resilient and nutrient dense crops. And to conclude the day, we will have a lecture on natural sweeteners, food security aspects, sustainability, and health impacts, which will bring together the aspects of health, sustainability, and policy relevance of using natural sweeteners. It's truly a pleasure to have Dr. Thangalakshmi with us today to share her valuable insights. Before we begin the session, I'd like to invite Dr. Antonio Rapso and Dr. Tejpal Diva to kindly felicitate our national speaker and extend a heartfelt welcome on behalf of everyone present here. Dr. S. Thangalakshmi is an associate professor in the Department of Food Engineering at the National Institute of Food Technology, Entrepreneurship and Management, Kundli, where she has been serving since 2012. She holds a BE in Electronics and Communication Engineering from Madurai Kamraj University and an MTech in Automation and Robotics from GVTU, Lucknow. She earned her PhD in Food Engineering from NIFTAM in 2022. With over 20 years of experience in teaching and research, Dr. Thangalakshmi has made significant contributions to the field of food engineering. Her primary research interests include food printing and novel food processing technologies. She has authored over 30 scientific publications in reputed international journals and contributed to 4 book chapters. As a dedicated academic mentor, she has successfully supervised 20 MTech students and numerous BTech research projects. She is currently guiding PhD scholars in a specialized research domain. In addition to her academic engagements, Dr. Thangalakshmi is actively involved in the scholarly community. She serves as a reviewer and editorial board member for various internationally recognized journals. She has carried out a number of industry-sponsored research projects. Her multidisciplinary background in engineering and food technology, coupled with her ongoing research in emerging areas, positions her as a valuable contributor to the advancement of food engineering and innovation. Now, I would like to warmly invite Dr. S. Thangalakshmi to kindly take over and share her valuable insights with us. Ma'am, the stage is all yours.
Thank you, dear. Thank you, Dr. Tejpal, for this invitation and this opportunity to visit CUH for the first time. Good morning, all of you. It's a privilege to be here and a part of this course. Uh, how many of you have heard about the term food printing? Before I start, I just want to know whether you know about this term or you are hearing this term for the first time, and it can be an interactive session. Maybe first session, I have 2 sessions for the day. First session, you can hear it out. Even still, if you have any doubts, you can ask me at any point of time. And the second session, I would prefer it to be an interactive one, so that we will have a break first, and I'll give you some questions to think about it and come back after the break, so that we will have an interactive session in the second one, rather than it's a one-sided lecture. I would prefer it to be an interactive one. So first, tell me, since I have heard from Dr. Tejpal that it's a very multidisciplinary composition over here. People from varied and different backgrounds. So it is important for me to understand the type of audience, so that I can deliver to the most possible, so that the reach is good. How many of you have heard the term food printing first? Please raise your hands if you have heard the term food printing. No, you have not heard the term food printing. Okay. Then if it goes very much heavy or higher for you, you just let me know, because some technical points also I have to cover. So I have tried to cover it to the possible extent over here. Okay. So food printing. Before through the mouse. Okay, it's interactive one. Okay, so before starting into it, I would like to give a brief a layman understanding of what is food printing. You know printing in general, right? Printing is, it's actually a two-dimensional printing what we do. Even if you have not heard the term food printing, you would have seen or used 3D printing structures. In mechanical, it is a very established field, 3D printing, where many parts are being printed. When a part is being printed, 2D printing will have only X and Y axis, just like on your paper. 3D printing will add an Z axis to it. It's a three-dimensional object that is being printed. So in mechanical, maybe PLA, there is plastic based products are printed to a larger extent. 3D exact size, small size structures are buildings. When you see some buildings over there, which is exactly the smaller dimension of an actual building. In Parliament, if you go, there is a smaller Parliament, overall structure is shown. If you go to some temples, some structure is shown. Or cars, if you have played with cars when you are small, exactly the scaled down version of complex car models are there. So they are all 3D printed. So in mechanical, in aeronautical parts also, a lot of parts and structures are 3D printed. So you get very good strength using 3D printing rather than molds. In molds, there can be spaces or vacant parts inside it, but in 3D printing, you can fill it as per the requirement. And in a medical field also, dental fixtures, some models, dental models are 3D printed. So 3D printing is an established field in terms of other mechanical or in medical fields. It is coming to a larger extent. Food is just following up in that line. So printing food, giving a three-dimensional structure to a edible component, an edible raw material, that is actually what is 3D food printing. So you can just understand it as food printing. This dimension is a variable one. We will see what is 3D. There are 4D also, there are 5D also, there are 6D also, which are all coming up. So in general, rather than 3D, you can understand it as food printing, where an edible material is given an X dimension, a Y dimension, along with that an Z dimension. Any structure which is built. You can imagine you always have your Kaju Katli in your diamond shapes. Why don't we have Kaju Katli as a spherical ball with hollow inside it? Why can't we have a Kaju Katli which is in the shape of an Eiffel Tower? Same Kaju Katli material, base material is the same, you get structures. So that is what is actually food printing. So with that, we will start with the presentation over here. I'll try to cover the entire presentation in these parts, where we will cover the different techniques which is available in food printing, the control parameters of the printer which are usually used and to be controlled, the advancements in food printing, that is your 4D, 5D and 6D structures, what is the global status of food printing as of now, what are the challenges in usually we face, or what are the existing challenges in implementing this technology, and what we do at NIFTEM and the future scope. So how do we define 3D which you want to print from your software, give it to your hardware component or your printer, and this printer will work as per the design, and the structure which is required is built layer by layer. So that is why it is also called as additive manufacturing. Additive manufacturing is a common term which is used in mechanical also, in food also. By adding layer by layer, we do additive manufacturing. In molds and all, it is subtractive manufacturing. You fill that any mold, remove the extra material over there, and you take out the required structure. But that is subtractive manufacturing. In subtractive manufacturing, food losses are also always there. The extra material which you remove can be accounted under losses. But in additive manufacturing, the most important or positive point of this is there is no food wastage. You print or you extrude only the material or only the design that is required. So layer by layer you keep on adding. So it is called fused. Other term is, one is AM, that is additive manufacturing. It can also be referred to as FDM, fused deposition modeling. So where you fuse, each layer get fused with the previous layer and it is deposited layer by layer. So it can also be referred to as AM, additive manufacturing, or FDM, fused deposition modeling. So going to the history, the first patent was filed for 3D printing by Dr. Kodama in Japan. RP refers to rapid prototyping. That is also a term usually used for 3D printing, and that patent was, for the first time, it was declined. It was not allotted, and the first successful patent went to Charles Hull in 1986 for selective laser application. So that is also a mechanical base. That is, the concept of 3D printing came into existence as a patented technology in 1986. And for food, in respect to food, the forerunner is HOD Lipson of Cornell University. He was the first one who developed a food printer and gave a proven concept of food printing over there, and it started in 2007. So you can see this is a very new field where it has started in 2007, and we are only 20 years down the line of that technology. So there is a lot of work which is going on, and lot of research is still pending in this field. So 3D food printing means, how do we define technically, is that it is to mix different ingredients which are suitable for printing, and to get the most important part of 3D food printing is to get the most intricate shapes and structures which is impossible to be made or uneconomical using other conventional methods. So you can achieve a personalized shape or structure or size which is not usually so much available in a normal conventional manufacturing methods. And you can have entirely novel textures and flavors which are very difficult or unimaginable to be produced by traditional cooking processes, and you can have a standardized recipe, a digital age digital cooking. The one thing which India lags behind is that we have a variety of cuisine all over the country, but we don't have standardized outlets. Just like McDonald's, if you take, they have a standardized outlet. Whatever quality or whatever taste you get, if you get in the US, the same thing you will get in India also. But in Indian cuisines, this is one thing that is pending. We have still a few players over there, just like Haldiram's, who are having international outlets over there. But still a lot can be done if we digitize those recipes. If we have a standard method, even suppose idli, if you take, if you go and have idli from South India actually, and you take the same idli from a North Indian restaurant, there will be a Zameen Asman ka difference will be there. We know South Indians can never have idli from a North Indian Haldiram, because there is a difference in that recipe, how they make. Even my friends who take idli from my house, they will say we can never have idli from here. The difference is there. So because that is, the recipes are not digitized, not standardized, in other terms. You don't have a standardized recipe. To standardize anything, you have to start standardizing from the raw material itself. Quality, quantity, everything has to be standardized over there. So that can be done if we bring in this type of digital technologies into the cuisine or the cooking part of that. So this can also contribute in promoting, developing our own traditional recipes, standardizing this recipe where you need some skilled manpower, skilled labor is required to do something. So if you have a digitalized recipe and a machine which can do that, standardized all over the world, then you can remove that parity because of the absence of expertise or absence of skilled manpower over there. So how do we define, or what is the schematic, how do we in general understand 3D food printing? Is that we have a material input component, tempering unit, can be a mixing unit, may or may not be present in all printers. Then there will be a pump which will push the material into an extruder head. There are different types of printing techniques which we will see in the next few slides. But in general, the most commonly used type of 3D printer is an extruder type. Extruder, you can understand just like a syringe. If you put something in a syringe and push it through the piston over there, the material comes out of it. So extruder is a sort of that. So extruder based printers are the most commonly and widely used type of 3D printers among all other categories here. That is one part where the raw material comes in. The other part is where the model comes in, and you have to have a proper software which is compatible, and through the software you select the type of model or type of object you want to print, and that model will then control the motors of your 3D printer, how the motor has to move. So if we have a square over there, then or a rectangle, it will have an x-axis value, how much distance it will move on the x-axis, y-axis and z-axis. So that is controlled by the motor controller over there. So from the model, the motor control parameters comes in. So when these two get merged, you will get your material on the deposition platform. From the material, once it is also optimized, there are two types of optimization which has to take place to make the material printable. One, the ingredient has to be optimized for printing. The other one is your printer control parameters have to be optimized. When both are optimized and both are coinciding with one another, then you get a successful 3D printed object on your design platform. So this is what is a food process additive manufacturing over there. As I told you, additive manufacturing is adding layer by layer. So in basically the materials, food materials are classified into 2 or 3 categories. One is the natively printable materials. Some materials by nature itself, they have a characteristic which they can be easily printable. Another category is the non-printable food materials. So natively printable, what comes here is your maybe cheese, which is in a flowable form, chocolate, that is, it is in a hot format so that it is easily extrudable. You can just imagine which you can pump through a syringe, that will come under the categories hummus, peanut butter. These are all native, cream. These are all natively jam. They are all natively printable. They can easily extrude from the extruder. Another one is the category is the non-printable material. Matlab in general used products, just like our fruits and vegetables, are no, they are not natively printable. You can make them printable by some variations, mash them, remove water or add water based on the composition of that, maybe add some hydrocolloids or add some starch to make it printable like that. So you can make the non-printable as printable by some alteration, maybe by some pre-treatments or doing something, you can make it printable. The other category is the alternative category, where in general you don't have a category of they are printable or not printable. In that alternative category, you have fungi, you have insect proteins, which are under the alternative categories, which can be made printable by some modifications of their basic structure or basic composition. From that, one side you have this materials, other one side you have the model. So using modeling, one is you can take the model either. There are different ways by which the software allows you to pick up a model which you want to print. One is from the internet. Any structure of this file type can be acceptable for the system. Or the third type by which the model can be chosen is using a scanner. You want just to print this bottle, you just want to sit and print this bottle, you have a scanner with you, you can scan this bottle from all the sides, that scanner will create a compatible file, then that file can be used to do the printing. So we have done this, we had a head of a small image of a head, so we tried to scan it, and the scanner picked up that image and converted into a compatible file format, then that we used to print. So using a scanner, you can abstract any object which is in the environment. Anything you want to print, you can just scan it and convert it into the file and do the printing. So there are basically three methods by which you can choose the object you want to print. So that is the other side which is coming in, which comes in the format of, usually in 3D printer we have a term called as G codes. So the G codes are generated for the image which you choose to print. So when that comes to the printer and the exact formulation which you have made the ingredients made to be printable as such, that also comes over here, then the 3D printing goes on. So there are four types of printing which can happen. That is, one is your extrusion, the second one is your inkjet, third is your binder jetting, and fourth is your selective laser sintering. I will talk about this in the next slide, the four types. Then once the image is printed, once the object is printed using your appropriate printer, then the last step is your post processing. So some objects may not need post processing. Maybe if you are printing chocolate, you don't need any post processing. Post processing means any processing application that is applied to the food to make it edible or to extend its shelf life. Anything you want to do. If you print a raw dough, then you have to do some post processing to make it edible. So that is post processing. So here it is very important to choose the type of post processing, because after post processing the structure should be able to retain its shape. So such type of post processing have to be chosen. So one of the established and easy method in which structure changes does not occur so much is, one is steaming, where you just print the object, keep it inside, you steam it. The other one is baking. So in baking, but the raw material should be strong enough, because it is exposed to very high temperature inside a baking oven. So it should not melt away during baking. So there are different types of post processing which are reported, maybe microwave, deep frying, or steaming, or these are, or drying, deep freezing. These are all some type of post processing which are reported to make it finally edible. Okay. So now this is the first or the primary question. Why do we want to print food? What is the need? As such, we are having food. Why do we need to print food? Okay, so we can put that under different categories. The reason for printing food, one is personalized food. Based on individual's choice, because we are now heading towards a developed economy where individual choices have to be respected. So a person's individual choice based on, I want to add this one or something else, you can have an outlet over there where someone having a vitamin D deficiency can come and have a vitamin D enriched some product. Someone can have a vitamin B12 enriched product over there. So at the same time, making it attractive, you offer some extra nutritional benefit in that product, so that parents also, when they give to their kids or something, without any guilt, they can give the product to them. Or iron enriched product. So personalized nutrition is one thing where you can have it. In addition to that, personalized nutrition specific application is for dysphagia patients. Do you understand? You have medical students here who are dysphagia patients. Yes, those who have a difficulty in swallowing the food. So, since we are moving towards an age where we are expected to have a higher number of geriatric patients or old age population will keep increasing in India. As of now, we are a very young nation where we have the younger population to a larger extent. Now, when we move towards that, or the countries which are moving towards that, just like China, Japan, which are having an aging population, they have to address the aging population's basic demands or most commonly reported problems. In that, dysphagia is one such category where swallowing difficulties will be there. They will not be, that is, the person who is suffering from that will not be able to swallow solid foods. So they want semi-solid food all the time. All the time you give porridge to them, anyone can get bored. So for dysphagia patients, this has been proven and proven as a convenient and a proven solution for that, so that you can print a variety of foods which are calorie rich, because they cannot have much within a small quantity of food. You have to provide the required calories to them. So calorie rich food and giving shape and structure makes them feel good, because food is not only for our energy and consumption, it is a emotion. Actually, food is an emotion. You love food not only for what you taste, for the appearance, for the smell, for everything, for the texture, for the touch you want, everything is incorporated in the food. So that is why we cannot have the same food every day. We want variety in that. So that is given using this for a specific. So that also can be coming under personalized nutrition for a specific population or for a specific category of people. You target food products that will come under personalized. Alternative ingredients, protein importance is coming on stage a lot. So we are searching for alternative ingredients. So alternative ingredients like algae, grasses and insect proteins, these are all easily printable. So you can have it and make it attractive, so that you have an alternative source available over there for protein. Convenience food, it can act as a personal chef plus microwave. As of now, we don't have there are one or two food printers which offer cooking along with printing. There will be printer also inside it. So once it is printed, it can be cooked also. You can give the heating options to it like that. So if it is done, then it is a personalized chef sort. Design freedom, that is the most important one in 3D printing. You can attain innovative shapes, structures and other things which is not actually possible using normal mechanisms. So when we have to print food, the properties of the ingredients plays a very critical role. Whether the material is printable or not, that itself is a big challenge. Now most of the papers are coming based on this only, that reporting different variety of materials as printable. So how do we report that? The properties of food material plays a very critical role in making it printable. So if we have rheological properties in which we can estimate the flowability and viscosity, that rheological property plays an important role in the printability. The ones within that diamond shapes, they are the characteristics of the printed material, and those within the circle, other things, they are the property of the material. So material properties, how it is coinciding with the printability properties or the printed product properties, is that the rheological properties will play an important role in printability. How it is flowable, how hard it is, how strong is the structure. So for a material to be printable, two main characteristics have to be taken into consideration. One is it should be flowable. That is, it should be able to extrude from a syringe sort. The other thing is, so extrudable, if you say the dough of a dosa, if you have seen dosa dough, is it extrudable? Will it be extrudable? So can we use it for a printing application? No, because there is another property also which comes into effect to make a product to be printable. Once it is not only printing, the other thing is, once printed, you get a Z axis over there, maybe 2 centimeter, 3 centimeter at least. When you get that Z axis, the material should have a structural strength to retain that shape also. So if you print dosa dough using that printer, will it have that strength to retain over there, to take up that 10 layers over there? So now tell me whether your dosa batter, is it a printable product? No. So for a material to be classified as a printable product, two main categories or two main points have to be taken into consideration. One is it should be extrudable. Other thing is, once extruded, it should have a structural strength to retain its shape for at least 1 centimeter or something like that. So your that roti dough, whether it is printable, हाँ, रोटी के लिए जो आटा गूंथते हैं, whether that is printable, हाँ, no. As such, in which composition it is for a roti, it is not printable. It is too hard to be extruded from a syringe, right? So this is the balance that has to attain. It has to be somewhere between your roti dough and your semi-solid sort. Semi-solid sort in the sort baby food, when you mix it, it will be extrudable, but again it will not have the strength to retain its structure. Okay, so chocolate in a specific temperature, they can retain the shape to some extent, but it has to cool down immediately once it is printed. One layer printed, it has to cool down. Then the next layer can come, it can cool down. There are cooling plates available. There are fans available which are kept closer to your printer, so that once the one layer is printed, it is immediately dried before the next layer is placed on top of it. Okay. Heating plates are there, but I doubt it will, because when even if it is cooked, when you put the next, it will spread out. It should have a structure that the nozzle diameters will be 1 mm sort, 1.5 mm. When it comes out of it, it will just spread out. Its spreadability is very high. That spreadability. So cookie dough, when you make it, it has to add some hydrocolloid something to make it a bit of one example is, have you used rice flour somewhere? So rice flour in a medium composition. So coming to the techniques which are usually available, the first is our extrusion based. As I told you, it is a syringe based one. Syringe based, where the material is pushed out of the syringe nozzle. So by what mechanism you are pushing, that is also different. There are different mechanisms over there, but all of them will come under extrusion based. One is either you push the piston down there, or some air can be there, which can, using pneumatic pressure also, the material can be extruded out, or there can be coaxial types rods over there which will push the material outside. So irrespective of by what method you are extruding the material out, all of them will come under the extrusion base. The other one is the SLS, selective laser sintering printing. Selective lasers are printed using food printers. These are sugar based products. So that is used, manufactured using your that is selective laser sintering or your binder jetting mechanism. You can see it is difficult to make such structures in a normal or a traditional mechanism. So such complicated 3D structures can be made. The above one is a printed one, then that is a post-processed one. Deep frying has been used, that is a meat product which is printed, and then deep frying has been used as a post-processing mechanism, and we are getting, that is, it's a proven method where the shape and structure is retained after printing also. So they are some of the other 3D printed products here. They are not actually what they are shown. Corn which is shown is not actually corn. From a base material, they have printed the structure of a sweet corn over there. And chicken legs piece which is printed, that is using some alternative protein, vegetable based protein product is printed of this shape. Okay. So that is one. So we have seen the material. First thing when you want to print is your material composition has to be optimized. So for that we have seen two material properties which are very important in making the material printable. So once the material is made printable, it does not give you assurance that it will be printed. So there is another composition which also has to be optimized, and that is your printer control parameters. That also plays a very important role in making your product printable. So that printer control parameters, in addition to this, the first one which is written in bold is the ingredient combination. That is the most important thing which you have to work upon to get a material printed. The others, these are all the parameters, that is the printer control parameters, which also plays an important role in making the raw material printable. We will see one by one. So print speed means at what speed your printer head is moving on your deposition platform. That is called as your print speed. So typical print speeds are usually 20 mm per second or 30 mm per second, like that. So it moves, the head will move in that speed. So it has to be optimized. If you have a higher print speed, what will happen? What can be the pro and what can be the con of a higher print speed means the head, it moves in what speed. Suppose you are making a square, presume using a printable, your material is printable, you have established that. Now you have a print speed to be set. One is you can have a very high print speed, one you can have a very low print speed, and you have to optimize between the two. That is the best. Now if you have a high print speed, what can be the cons of that and what can be the pros of that? Precision, it is an equipment, it is a machine. You can't compare it to a human fastness. Whatever speed you give, the machine will move in that speed. Its precision will not differ. That is the difference between, if I do it very fast, I can make a mistake. But if it is within the limits of the equipment, doing it. Do you understand what I mean to say, right? Now precision in terms of what? The machine is not going to make any error. It is within the workable limit of the machine. What can be the positive? You tell me positive. If it prints faster, what can be the positive output of that? That is one overall limitation which is in general talked about is 3D printing is a slow process, not so much adapted for mass production. That is an overall implication of that. Research is going on and problem is being addressed, but that is a in general one. At research level, yes, that exists. So if you increase the print speed, yes, obviously the time required for printing will reduce. Correct? That is one advantage of that. Then what can be the limitation? Time to proper? No, strength is not dependent on time here. Yes. Now we are talking about time less. Print speed is higher. First we are talking about this term. Let's finish its pro and con. So now we are having a less time. Now tell me what is the disadvantage of having a lesser time for printing an object. Yes.
Destroy the food safe.
Destroy the food shape. Okay. To an extent. I'll explain that. Any other point? You were saying something. You can complete your statement. Okay, set you were said. Okay. Anything else?
Ma'am, some material need time to dry. So in that case, if we are reducing time, that layer will not be dried properly.
Usually in printing, we don't expect the previous layer to dry. If it dries, fusion will not happen. We want it to be fresh. So because it is fusion deposition modeling, it has to fuse with the previous layer. How much it fuses is an advantage for printing. So you don't expect it to dry as such. Anything else? Actually, the material when you extrude, it is a biological material, right? It will need some time to extrude. It is not that they will extrude as such so faster, because we are making the material so that it is having some strength also. Strength means you have to then, how much strong it is, that much difficult it becomes to extrude from your extruder, right? Then you have to put in that much force over there. So it will take some time for the material to extrude out of the extruder. So if you move faster, what will happen? The material may not have been extruded from your nozzle, but your printer has moved from your actual position. So there will be gaps in between. The material will not be fully extruded. You have to give time for the material to extrude and move it at an optimized speed so that extrusion also happens and it lies exactly over the previous line. So that is the optimization you have to have. The other one, if you make it slow, what happens? One is time. It will take a longer time to print. Then in terms of extrusion and setting, what is the problem that will happen if you have a slower print speed?
Discontinuation in extruding material.
Discontinuation will happen when you move fast. When you move faster, the material may not have come out properly and it is setting on your previous layer. Right? If you move slow, discontinuity will not happen because material will be coming out continuously in a slow moving printer. So
More
what is the
material will be consumed.
huh?
More raw material will be consumed.
So what will happen to the structure there? Because we are more
Overlapping.
concerned about the structure now. Very good. That is the point. That is called as over extrusion will happen. You want only one line to be extruded when moving over the square, but over extrusion there will be a lot of material moving there, but the printer is not moving, so more material will get accumulated in places where it is moving. So that is called over extrusion. So over extrusion will happen if you have a slower print speed. So that is the purpose, that you should have an optimized print speed. Not too high, not too low. So that is done usually by experimentation, that you reach an optimized print speed over there. So that is the importance of print speed and selection of an optimized print speed while printing a food material. And the other one is layer height. Layer height means when you print one layer, the printer will move a bit higher to allow space for the next layer to be printed. So the next layer will be printed, then it will move maybe 1 mm or 0.5 mm is an average value by which it moves up. So the next layer it will move, it will print. So once it is printed, that layer is filled. So it has to move further up. Each time it goes a step up over there to allow the object to develop from a layer by layer method. So that height by which it moves each time over in the Z axis, that is called as layer height. Okay, so that also has to be optimized. If you have a higher layer height, what will happen? Higher layer height means suppose it is 1.5 mm. What will happen? Yes, there will be space. It has to move exactly over the object to maintain the object structure. If you leave space between your base where it is printing and it goes up then your extruding material will not sit properly on that layer. It has to exactly move over the structure. So then the space, when it increases, structural disability or structural imbalance occurs. क्योंकि नीचे का layer, it is not touching, the above layer will move here and there, then zigzag patterns will happen because material is coming but it is in air. The material has to have the base to set continuously. If you extrude the material in air, the material will move then. It has to move, it has to extrude exactly on the layer only, previous layer only. Okay, so if you have a lesser layer height, maybe 0.5 mm, previously I told 1.5, now if it is 0.5 mm, what will happen here? Not beside it, how can you put it better? Yeah, it will actually pierce through your actual printed product. Your shape is going to be affected because your nozzle has not gone up. You have put in material. It will keep moving on the shape, already printed shape only. It will move only a little bit higher. So piercing will happen of your already printed structure. So it has to move exactly above, and this is related to a larger extent on your nozzle diameter. Nozzle diameter means the size of the nozzle by which the material comes out. How it is related? Any guess? This layer height is a factor dependent on nozzle diameter.
Circle from the it's coming like the length. Sorry, so the breadth means the if it is one drop, we can say if it is like 0.5 mm, then the length will be of increased of 0.5 mm. So like that maybe.
That is what here it is shown. Here this is a smaller nozzle diameter material, that is a larger diameter material. So usually this layer height is kept as 0.75 percentage of nozzle diameter. So when the nozzle diameter is smaller, you are having a smaller, that is the radius or the diameter of the material coming outside will also be smaller. Take a noodles type. You have a different size of noodles, thinner noodles, thicker noodles. If you have a thinner noodles, the next layer has to be smaller than that. So it moves a little bit only to accommodate thus that dia of the material. So there will be some, it will not be exactly like the nozzle diameter, it will be a bit larger because of the swelling property of the food, biological material, and they always swell a bit. When you move it through a pressurized, just like extrusion mechanisms where swelling happens, here also extrusion is happening. So once it comes out, it swells a bit from its original nozzle diameter. So this layer height is a proportionately related to the nozzle diameter. So if you have a larger nozzle diameter, 0.75 of that is the optimum value, which is an established value, that it may vary a bit based on your material, based on its expansion properties. It may vary a bit, but it lies somewhere around that value only. Nozzle height, this is a very very less talked about parameter. Nozzle height means the first time where the nozzle is placed above your deposition platform. That is also called as nozzle base distance. So nozzle base distance, how far it is from your base while beginning the printing, that is very important. You have to keep it at optimum. If it is higher, then again the first layer is very important to maintain the shape and structure of your object. If the first layer is built good, the next layers are easier to build. If your first layer is gone wrong, then the next layers will not retain its shape or structure over there. So this nozzle diameter, that is so nozzle distance is one important factor which decides the strength of your first layer. So it has to be optimally placed. After that, the layer height will take up. Whatever you have given in layer height, that much it will move each time. So nozzle height is the first time how high, at how much distance you are placing the nozzle tip from your base. That is the nozzle height. Nozzle diameter, as I talked to you, these are the standard values, but for food materials, these are very small. So we usually work at 1 mm, 1.6 mm tak we go. At 2 mm also it is printable, but shape or structure fineness is not there. Now can you tell me how is the nozzle diameter related to the fine structure of your object? Whether a very small one, what will happen? If it is very large, what will happen?
If it's large, the accurate shape which we need may not get. But if it's small, then the like if we are talking about the shape of the gummies, like if it's like a teddy bear shape, it's so the precision will be very high if the nozzle size is very small.
Taken. And what will be the limitation for a larger nozzle and what you have compared these two? Limitation of a lower nozzle diameter. Precision, lower nozzle diameter will have a better precision compared to a higher nozzle diameter device or a nozzle. What will be the limitation of the lower one?
Maybe time.
Yeah.
Less time to print.
Lower nozzle diameter.
Sorry, lower diameter will take more time to print as compared to the
Yes.
larger
A
diameter.
lesser diameter one will take more time to print because it will print from that smaller nozzle size, nozzle diameter only. So time taken will be more in that case.
And smaller diameter.
The other one is yes,
Clogging can happen.
yeah.
Small diameter.
Many materials will not extrude from a very
from
small
that.
one.
Because strength is
Yeah,
also kept in mind.
these things we have worked a lot in 3D printing, but till we have not used any 0.mm nozzle. At least we go up to 1.25 or 1.6 mm. 1.6 is the most optimal, where it is for image purpose it is shown here, but for practical purposes we use around 1.25 or at least 1.25, or we go up to 1.6 mm. We cannot vary it in between because there are standard sizes available only. You can use only that. You cannot have 1.3, 1.4 as you wish. That which can be done in print speed, layer height and all, you can set anything because that is a software setting. But this is a hardware which is available as standard values, only that can be used. The other one is the infill level or infill density. You can see here the pattern which is made inside it is called as the infill density or infill level. These are the different designs which is available in general software. What design you can choose for the infill. The other one is the density over there. Now tell me, what is the advantage of using an infill? For the entire, suppose you are making a square over there. If you choose this structure over there, honeycomb is a normal structure which is used, and honeycomb you can choose 10% honeycomb filling, or you can go up to 40% honeycomb filling, like that. So shape you have to choose from here. For the entire image or entire structure, this will be filled inside. So what can be the purpose of this?
It can provide structural support.
Yes. One is it will provide structure, strength. If you make only the outer line, the image or the picture may not be that much strong. So if you fill it, the entire structure will take up a strength over there. Suppose you are printing a Taj Mahal. So in Taj Mahal, if you see the center one, if you use zero infill, it will be a hollow one. It is difficult for the structure to retain its shape. It may bend somewhere or fall off somewhere. But if you use an infill over there, अंदर वो fill होके आ रहा है. So when the upper tomb it goes up, there also the filling will go. According to the shape, it will reduce the size over there. So any structure will get a strength when you give the infill to it. So if you have a very high infill, then advantage and limitation. Yes, time and material consumption will be very high. You put in a lot of material in that. Then very low means strength, will not be there. So you have to, here also you have to choose an optimal one. And this can also be used for the next level of printing. Maybe 4D or something, you can fill anything inside the honeycomb and give a post processing to it. After that there can be a different structure or shape. Suppose momos hai aapka. momos hamesha why it is in this shape or other. You can print, have something inside it, give a steaming over there. You can have that structure then, a Taj Mahal type momos with a filling in there. If you have a multi-head printer, you can print the shape using a different head and give the filling using the second head. So, one layer printed, the filler will come, make the filling. Next layer printed, the next layer filler will come, it will give the inside filling. So, once it is done, you can take it, steam it, the best possible post-processing method over there, you have a different shape there. Or something enriched interior also you can have. So, for children, if you give a normal shape, they will not take. But if you have to make them eat something which is nutritious for the shape, they will have it. So, that is one thing to attract kids, personalized nutrition, all this can come up here. So, post-processing we already talked why we need post-processing. If it is a ready to eat product, you don't need any post-processing. Based on the raw material, if it is a dough or something sort which needs cooking, you have to go for post-processing. So, that can be done. So, these are some of the 3D printed bakery products here, which you can see different shapes and structures. So, we can continue. Okay, we can continue from 4D because they have come to a newer topic, so we can break and continue later. Okay, so we'll continue. Okay, will be here.
Let's continue with the next session. It's my pleasure to once again invite Dr. Thanga Lakshmi ma'am to the stage to resume her insightful lecture. Over to you, ma'am.
Thank you. Hope you understood a basic part of food printing. Now moving on with the advanced technologies which is available in food printing after 3D. The next one is 4D. Now in 4D it refers to some evolution of the product which you have printed, either in terms of color, some aroma or flavor or shape or nutritional value. So evolution means some change will happen in either of these parameters. So once the product is printed, there is one concept which is called a stimulus over here. In to make a product as 4D printed in addition to 3D printing, once the product is printed, a stimulus is to be applied, some catalyzing parameter over there which will make or which will induce that change or which will induce that evolution in terms of either there will be a small change in shape or some structure or its color or aroma, something will change over there in response to the stimulus. So that is called as 4D printing. So here there will be a bit more of customization over there in addition to your 3D. So this is a picture schematic representation of what is 4D printing. So in 3D printing we have seen that we have a 3D printer and a material. In combination with these two we can get a 3D printed structure. In 4D what happens? You have a structure, then a stimulus is applied. You see a stimulus is being applied, then we get a dynamic structure. Something changes in that structure. Maybe its color will change or some structural change will happen, which will make it, then the component or printing will come under the umbrella term of 4D printing, the next advancement in 3D. So these are some of the 4D printed and reported work which is there in the literature. So by using anthocyanins, which is a bioactive component over there, and the stimulus here is pH. When we have incorporated, there should be a bioactive material or stimuli, that is also called a stimuli responsive material. There should be a stimuli responsive material incorporated in the basic structure, and we apply the stimulus to that printed product. Here the stimulus is pH. So this anthocyanin will respond in reference to the different pH levels. So with response to under different pH conditions, you can see there is a color change. In different pH, it behaves in a different pattern. So this will come under the category of 4D printing. Another one is there where there is also a pH variation also, where betalins is used, that is also a bioactive compound present over there, and here the stimulus is also pH. So on application of pH, we get a color change in that also, which is not that much visible in your image in this screen over here, but there is a color change with response to pH variation. The other one we are seeing here is the extract. It is an extract using lemon yellow solution, and the stimulus is here is sodium bicarbonate. So on application of sodium bicarbonate solution, the printed product was like this. So after printing and spraying of the sodium bicarbonate solution, there is a color change. The creamish color changes into a light green color over there. So that will also come under 4D printing. The other one is where lotus root powder is used here, along with curcumin emulsion, which is used as a bioactive material here, and the stimulus is microwave treatment. So we know that curcumin has a property which will change with respect to either pH also it will change, or with respect to heat treatment also there is a change. So you can see the color variation in this one also. So this is the examples here all shows some example of color transformation. Here the term used is called transformation. So either it has to undergo either a shape transformation or a color transformation or an aroma transformation or nutritional transformation. Mainly these four transformations will categorize the food into a 4D printed from a 3D printed category. We have the next advancement also over here, which is called as 5D printing. In 5D printing, what happens till now we have seen in 3D and 4D, we can usually construct horizontal, vertical, that is in x and y axis straight movements. Here in 5D, there is a curved movement over there. Your head can move in a curved fashion also. Otherwise, you have a head, this will move like this only. So any change over there can be done only by your x axis, y axis and the z movement. Here there is the head will move in a curved pattern also, and it will stand there and it will print, which you can see here. The head is standing in a curved position where curved structures can also be printed. So printing of here there is other axis in addition to x, y and z axis, there are two rotational axes also involved, which will add to the 5D dimension of the printed object. So you can see a spherical tome jaise, you can print something like that, which is of a sphere type, which is usually difficult to print using a simple 3D or 4D one. So in 5D here what happens, 5D you do a printing of a curved structures. The main emphasis here, the main emphasis in 5D printing is printing of curved structures, which is not defined in 3D or 4D. And 6D, the next evolution is to a curved structure we apply a stimulus, then it becomes a dynamic structure over there. To a static curved structure we apply a stimulus, it becomes a dynamic structure. Maybe a lotus is printed, on applying stimulus the lotus may bloom. You can print a bud, it will bloom on applying something over there as a stimulus material. Maybe you can heat it, microwave treatment you give, because of heat maybe some structural change is there, that will come under your 6D. So 5D and 6D are conceptually now available, but not much of work has been reported, because first the printer has to be available to do that, then you can apply it for food. Okay, so 5D and 6D is not that much practically available materials are as of now. So applications of 5D, where do we use it is We can use to print complex shape like a ball shaped confectionery item. You want to print a ball shaped some chocolate or some other sweet or something like that. So for ball shaped you can use concave shaped chips or snacks, complex shaped boxes for packaging, and cups and bowls for edible ware. So in 6D printing what happens? So 5D, this is already explained. You have a curved structure and application of a heat stimuli, inclined stimuli, you get a further structure over there. So this is the overall application areas where these, so we have seen what is basically food printing, types of food printers, then moving on to the advanced, the printer control parameters, what are required, then moving on to the advanced printer availabilities, that is 4D, 5D and 6D, then in general where the applications are there for food printing. So first one is our personalized nutrition. We have discussed a bit on personalized nutrition. Then athletic, that is personalized nutrition means you can target specific groups of people. So it can be either pregnant ladies, it can be athletes, it can be kids, or it can be aged people or something. So it can be a personalized area. Flavor and texture modifications can be achieved. Food aesthetics, that is the most important point of food printing. Medically tailored foods, under which comes your dysphagia foods also. Food for space travel, this is also one of the reported one. NASA is also looking at food printing as a possible option for astronauts in space. Food for military application and for specific decoration applications. So innovative inputs which are there in food printing is insect enriched printing. We can use software for slicing and application uses over there. Modified foods are an innovative application here. Enrichment of nutritious food in children. For children, specific category iron rich, like that you can make targeted foods for them. Preventing wastage of perishables and sustainability, as I told you, food wastage is removed in printing because it is an additive manufacturing type rather than subtractive manufacturing. 3D bioprinting, bioprinting is actually a subdivision here. So bioprinting, technically you can use the term bioprinting only when tissue culture is used over there. Tissues are used in printing. So it can be either for consumption or it can be in medical field also. In medical field, body parts are also being printed. Maybe there is an established year. This year has been this external pinna of the year. This part has been printed by using human tissues. So that is tested on guinea pigs. Their ears are being printed. So that is a part of bioprinting. In tissue for food, when you see, it is in terms of cultured meat and all. So that will come under the category of bioprinting. So when we use the bioprinting term, it involves printing of living cells, all cultures. Okay, and 4D printing and post printing characters. So these are the commercially available 3D food printers in the market. We have all these food printers which are commercially available for use. Continuing with that, we have all these printers available. There are some vendors in India also. This is one of the established vendor, FabForge. It's a Coimbatore based company. We have purchased a few printers from them also. They provide good solutions in India. And global market potential. What is the global food printing status? So the market is predicted to be 0.68 billion in 2024. It was a 2022 survey that was available, and it is projected to grow to USD 2.71 billion in 2029. This is exclusively food printing market. And these are some of the companies and countries where commercially available 3D printed solutions are available here. The top being the Israel, they produce this The company name is Redefined Meat. They produce plant-based meat products. That is, alternative protein products are being printed. In addition to this, we have some companies in Netherlands also. They are also producing 3D printed products, some dairy based in a very large scale for a commercial unit application. It is there in Singapore also. Commercial printing is available over there. In India, there is a company called as Sugar and Space, which is a Mumbai based company. They have started 3D printing applications for a commercial production especially for hospital and dysphagia patients. They have link up with hospital so that they started printing food for these dysphagia patients, because that is an established application of 3D food printing. In addition, they are also into printing these waste materials which comes out of these food companies, just like fruits and vegetable company. In these things they are trying to use it. So it's an established company over there in Mumbai. So that is the current update on what is going around the world and India in 3D food printing market. This is the overall market scale of 3D food printing, where it is being used and by whom. What is the market share for different applications? You can see hospital application holds 21% of its overall application. These are some of the startups around the world which is working on 3D food printing. The 5 top emerging 3D food printing startups here. You in US and mainly in the Europe. They are concentrated mainly in the Europe over here, and one in Japan also. The main challenges that is there in the food printing is standardization of printing materials. Biomaterials as such, they have a problem in standardization. Same composition, if I say that may be printable for me and you source that material from somewhere else, it may not be printable for you, because there is a variation in the biological nature of the material. Rice flour consumed from one area will be different in nature from the other. So that standardization is a very big challenge in food printing. Correlation of printers. Same raw material. I have 2 printers with me. It is easily printable in one, in the other printer I will face issues, because correlation of printer is also a different. The parameters will be different in one printer and other printer. So that basic correlation is required. Licensing issues, as of now, in India we don't have that much standardized FSSI regulations. It has come up in Europe for that contact surface materials should be food grade materials. That is one which is coming up in Europe. So licensing and this is an issue as of now. We don't have any standardized rules and regulations for printed food products. Hygiene has to be taken into account, because nozzles have very thin dia openings. So there is a possibility of microbial growth over there. Cleaning of the nozzles is an important issue. And legal regulations, yes, it is there. Safety and food regulation, the same thing. What is the financial aspect? We have to work out the economics, because as long as it is not accepted at a mass level, the cost will be at the higher side only. So that economy will come into effect only if it is used at a larger scale. So allergic reactions, models, when you take it from the internet, you have to make sure that it does not have a copyright issue over there. You take up models as such from the internet. Environmental aspects, no study has been done as of now relating it to whether it has a positive impact or a negative impact. There is an energy consumption, cost analysis. All this is not done. You don't see anything as of now related to this in the reported research papers. So at NIFTM we have basically these 3 printers. The last one is not updated here. We have 4 printers as of now at NIFTM. These are the materials we have printed at NIFTM for different applications. You can see the head I told you. This is from a scanner. We scanned an image and we tried to print that one. And inside you can see that honeycomb structure, infill we have given to give the shape, strength to that shape. Yes. So the future looks bright. but we can't say anything as of now. Commercialization is the key to it, that how far we are able to commercialize the products and make it industry friendly or at a commercial level, because everything is happening at the research level only. Thank you for the first presentation. I told you I'll put up a question for you. Now the question is there, then I'll continue for some time, I'll come back with the question. Now you can think about what you would like to print and why. How feasible is the product you are thinking? How feasible is that to be printed? Product, reason, and how feasible according to you. Right? Think about that and put it down. We will come back here. Yes. So it's actually a bit difficult to. Sir, इसके पहले I have a video. I would like to show the. I'll show you some videos of the printing which is happening over there, so that you can have a better idea before we go into the application part. And I would like this lecture to be an interactive one only, because applications I will talk only about which is a reported application. So if you want to take up your questions, I will go through a bit over there. I will stop and we'll have an interactive session. So based on time, I will cover that over there. One image which you have seen with an infill over there. The material here is some sorghum based material we have made, millet based cookies sort. We thought of filling inside with chocolate, so that after baking you will have a जैसे choco bites जैसे होता है, a biscuit and a chocolate inside it. So this is how the printer head moves. You can see it moves exactly over the previous layer, so that it follows the same line there. This is from the beginning, the first layer that is being printed. So it is important how high is that nozzle during the first layer printing. This base material here is badam, which is soaked overnight along with some sugar. We refer to it as marzipan paste. See, one layer is left out there here, because the speed is not matching with the extrusion over there. This got up to 2.5 centimeters. The z-axis height we were able to reach up to 2.5 centimeters. And the material strength is so good that it will retain shape even if you increase it here. And since it's a marzipan paste, we can, it's a ready to eat product. You need not have to cook it or something. So in this we will see only the applications, which are the reported applications here. We will see a few applications here. So the first one is animal based protein applications. So it's a 3D printed chicken nuggets here. You can see the shape which is obtained, and the basic composition here is refined wheat flour and ground chicken over there. So chicken nugget is printed. The second one, it's a whey based color changing ink. It's a 4D printing application using animal based protein, whey protein here. So this combines whey protein isolate with curcumin. So at different, here you can see on the left it is control, and different types of drying mechanism is used. Hot air drying, then microwave drying, like that different drying mechanisms. For different, the top line is the percentage, for different percentage of this nanoprotein incorporation over there. For plant-based protein, you can see for texture modified food for elderly. The first one is a texture modified food for the elderly. Here you can see it is based mainly on mung bean protein, along with rose powder incorporation and flaxseed gum. Flaxseed gum is used as a hydrocolloid. So it will act as a hydrocolloid also, and it will impart its benefits, health benefits also. So you can see the different structures which is it is able to retain over here. Then the next one is a pea protein based application, where we have a pea protein and cassava starch over there. So for different pH conditions it is checked. So for the pH 5 condition, you can see different temperature combination, pH and temperature combination is applied over here. For pH 5, 35 degree itself, it was very difficult to print it, and further temperatures it is not printable at all. So it is not at all under printable category. So others, you can have different images over here. The best printable here is the pH 3 combination at 60 degree centigrade. So that is the best printable one. So when you come to tissue printing, the most important that comes under food printing is cultured meat, which is called as bioprinting or tissue printing. So what happens in bioprinting basically? Stem cells are extracted from the animals which we want to grow. Maybe it may be a chicken, or it is from beef, or it is from fish. Stem cells are extracted from that, and these stem cells undergo growth in controlled environment and controlled conditions. For that, there are two types of printing which is available. One is for scaffold printing. Scaffold means the basic structure which is used to give strength. It is kept and the cells are placed inside a material over there. The cells will grow with the support of this scaffold. In body, what happens? We have bones and other things. Based on that support, the tissue grows or muscle grows. But if you grow it as such in a lab without any support, it will just fungus jaise badega wo. It will not get that strength. So to give it strength, scaffolds are printed using biomaterials which are food grade materials. So that is one area where food printing is used. These scaffolds are printed. The other one is once the tissue grows and you get a lab meat or a cultured meat over there, then that meat can be printed into an acceptable variant. Maybe you want different shapes for that. So that can be printed by combining the muscle cells, vascular cells, fat cells. A muscle is actually, meat tissue is actually a combination of all this. Then only you get that actual feel of having that meat product. So that is done using 3D printing then. So there are two main functions of 3D printing in cultured meat. One is during growing for scaffold printing, or after growth of that tissue for printing into acceptable structures, maybe in the shape of a leg piece or something, by combining muscle cells along with fat cells and vascular cells. All this has to be combined to get your final product. So there are a lot of advantages which is being discussed for cultured meat. Environmental advantage, there is no meaning of slaughter and all, it is all lab grown meat then. So methane production, which is all related to animal foods, that can be controlled with this cultured meat concept. So there are some reported research in cultured meat production also. One is your steak type cultured meat over there, which is printed using beef here with gelatin. So here you have to use some hydrocolloid which will act as a meat gum. So transglutaminase, like that product is there, which will act as a meat gum, which will combine those cells together. So you see the images there, that is what you get after printing over there. Before printing it will be like this. आप एक petri dish में it will be just like something grown over there. But to give it a shape, structure, texturization or strength to that product, 3D printing helps in that. The other one is plant-based plant protein enriched scaffolds. Scaffolds, as I told you, to allow the meat to grow in that. The scaffold can be printed. The third one is a steak-like meat, which is also printed here. So before the other applications, if I can take up a few questions or the question which I have given, if anyone has anything to discuss, we can take at least 2 discussions first, because I have applications only like this after that. Anyone who has thought about what you want to print, why do you want to print, and do you think that material is basically printable? 3 questions you have to present over.
So very good morning, ma'am.
Good morning.
I'm working on like millet-based products. So I'm thinking to if I can incorporate 3D printing in my with my food product, so I can make it like attractive for the children's and for the other population as well. I'm not sure whether I can do or not. I would like to know from you whether I can incorporate 3D printing with my product or not.
Okay. Millet is a very vast term. What do you want to develop from millet?
Ma'am, cookies.
Okay. We are at our lab, we have developed a 3D printed gluten-free cookies based on millet. It's a sorghum based cookies. We have done that. So you can have a targeted population for whom you want to print it. So millet as such, it is based on the floor and particle size and all, whether it is printable or not. That you can decide upon, which is, but first to decide your raw material, decide your target population. To whom you want to, if you are saying kids, then kids less than 5 years or 8 years, what type of nutrition you want, what is the most prevalent deficiency is there which you can address by, you have to make the kids consume it if they are not consuming it as such. So that is what you can incorporate using 3D printing. That is more shape related, where you can give in a single product. If they complete that product, they have to get a sizable amount of some nutrition. So you target that one, what you want to incorporate in that. Some incorporation will be good. And if you can get a 4D printed one over there, maybe something filled inside, or you get it something sort, when you put some water on it or sprinkle water on it, it will change color or something, you incorporate some color changing stimulus material over there. So you make it something attractive, which will attract the kids, which will have a higher edge on that, so that it will serve its purpose of attracting the kids. So rather than only 3D printing, you can think about 4D printing. What you can, if a chocolate is there inside, the kids will want it more. They will be ready to consume it further. So you can make it in shapes which is more attractive, maybe rocket shape, maybe bike, maybe car. Make it something which is more attractive. If you open the car, there is a chocolate inside. So like that you can incorporate some innovativeness to that, so that it becomes 4D printed also and it will serve your purpose also.
Thank you, ma'am.
You can tell your name and from which area you are, so that I can understand your perspective better.
My name is Samra. I am from Uttar Pradesh, Bareilly. Ma'am,
You are which student of scholar?
ma'am, I am from Nutrition Bio Department, MSc second year student.
Okay.
Ma'am, I would like to print a disaster relief nutrition pack. Like when we transport certain meals or things that are needed in the emergency situation, often they are not transported. If transported, they are destroyed when they are being consumed. So anything that can be printed having long shelf life and that contains the macro and micronutrients so that it can give relief in the emergency situation and provide the appropriate nutrients to the people who are in emergency. So that can be prepared.
What you want to print in that? My first question is, what do you want to print? What should be the raw material base?
A raw material it can be the millet or any other thing that can be used which can be extruded easily and can provide the macro and micronutrients like any chocolate like bars or anything in the form of bars we can print them.
I would request to be excused from this one, because disaster management food is an emergency food.
Yes, ma'am.
3D printing is a time consuming technology.
Okay.
So these two things cannot go hand in hand as per my understanding.
Ma'am, I was talking in terms of like shelf life and all. We can make such
There
things.
is no proven concept that 3D printing will improve shelf life in any way.
Okay. Means
It's not a it's not a topic at all that is discussed ever.
okay.
Shelf life, 3D printing will not have any role in shelf life.
Like when we provide some cooked or like materials that can be destroyed in a shelf life, so like we can make the cookies or things that is that can be transported easily by with the help of
3D printed structures become more difficult to transport.
Okay.
We talk about personalized nutrition, where over the counter you print something and give it to someone, they have it fresh.
Okay.
With a targeted nutrition requirement or accomplishment that can be done.
Okay, ma'am.
Transport, no. 3D is a big no.
Huh.
Because shape, structure as such, it is difficult to print and to post process and to keep the structure till you consume itself is a question of research as of now. So for transport, no. Then there is no personalized nutrition in 3D.
Okay, ma'am.
When you talk about personalized nutrition, it's usually a local one.
Okay, ma'am.
3D is that is the problem or negative points you can say. Every technology will have a positive and a negative point. There is no technology which will have only positive. So these are limitations. Structure stability after printing and retaining it, then you have to protect it, them in boxes, proper boxes, fragile, everything. Because you are not printing a plastic product.
Yes.
You just print it and send it anywhere, it will be like that. So shape retention will be an issue, and that topic I may not agree with as of now.
Ma'am, I thought that it will have stable and long shelf life also, that I was not knowing. So I said in terms of shelf life.
Okay.
So that it
In
cannot be
discussion,
destroyed.
there is nothing right wrong. You say something, I may agree, I may not agree. Maybe tomorrow you will prove that prove me wrong. That is what is research, and I'll accept. Okay, I'm wrong. I was wrong on that day, because it is an YouTube one. You will see it anytime. So I will accept if you do something like that. I'll accept. Okay, I was wrong. Science has evolved. That is all about science.
Yes, ma'am.
Science always evolves, and we have to accept when we are wrong. At this point of time, this is my statement. And it may change after a year or something.
Yes.
When research is reported on that, or I do a research on that, or you do something.
Yes, ma'am. Okay, thank you, ma'am.
Thank you. Thank you.
Good morning, ma'am.
Good morning.
Ma'am, I'm Dilshida. I'm from Kerala, Calicut, and I'm doing my master's in nutrition biology. So, like, I'm thinking, I'm like dry fruits. So it's expensive. So no, not everybody can afford it. So can we like build any 3D structured dry fruits with the same nutritional quality? So keeping in mind that composition of any resins or walnuts, anything, keeping the nutritional qualities of that, we can print like same structure. Maybe not in taste, we can't, but at least we can fulfill the nutritional needs so that it's
So what is the raw
affordable.
material you are proposing? I am asking you the raw material.
Like
You are
ma'am,
giving me a question.
yeah. Raw material, like I haven't thought about it. I'm just
Because
saying.
that will decide whether it is printable or not.
Yeah. Okay.
Yes, of course, printing something of that shape is yes, you can.
And
print.
also the nutritional
That will depend on your raw material, what you are going to choose. Whether you can print a cashew nut, I will say yes, you can print. I will restrict to that area only. What raw material comes and whether that raw material will satisfy the nutritional properties which is available in a dry fruit, that is a nutritional area. I am a printing expert, so I will say you bring a material, I will tell you whether it is printable or what are the addition or deletions you have to do in that. Add a hydrocolloid, give some ultrasonic pre-treatment, something which will increase the printability of that. Yes, printing anything of the shape of a dry fruit can be done, yes.
Thank you.
गुड आफ्टरनून मैम.
Good afternoon.
मैं प्रिंस पीएचडी स्कॉलर. मेरा वर्क एक्चुअली वेस्ट पे है और 2024 के वर्ल्ड फूड में एक्सपो में मैंने आपका 3D मॉडल देखा था जिसपे आपने मुझे दो ही याद है, मैं तो ऐसे बहुत सारे देखे थे, बट दो मॉडल, एक आपका बनाना पील का था और एक आपका शुगर कैन बैगास का था, जिसपे आपने उसके 3D बिस्किट्स में भी समथिंग बिस्किट्स या फिर
What is the first product you said?
एक बनाना पील.
Banana peel.
Yes, ma'am. And second is the sugarcane bagasse.
Both are not a product of Niftem K. Maybe Niftem Tanjore का तो नहीं है?
No, ma'am. Niftem K, definitely sure.
Okay.
तो
Yes, what do you want to ask on
actually,
that?
एग्रीकल्चर वेस्ट जो भी है, क्या हम उसको फिर आगे फर्दर ले जा करके उसके अंदर कुछ न्यूट्रिटिव कंपोनेंट को ऐड करके क्या फिर से उसको एडिबल के फॉर्म में ला सकते हैं? अगर
By theory and principle, yes. One limitation which I can understand theoretically is that agricultural waste or some food product waste will have a particle size, larger particle size. If you are able to dry it and powder it and bring it to a lower size which is extrudable through a nozzle, then I am fine with that. Printer will be able to work. Printer only means what is the shape or what is the end product size, whether it is extrudable through that or not. Your printer only understands that. It doesn't understand what that material is coming from.
No,
So if
as a our department represent, okay, तो अगर वेस्ट मटेरियल कुछ है तो अगर उसके अंदर हम कुछ बैटिव देते हैं और अगर आगे कुछ उसका प्रोडक्ट अगर डेवलप करते हैं और वो एक्सेप्टेबल होता है तो दैट इज अ गुड ना.
yeah, I'm saying that is good. But only thing is your product raw material should come in a powder form.
पाउडर का कुछ साइज वगैरह पर्टिकुलर इतना साइज?
Yeah, there is size. Actually, at least less than 100 micron size होना चाहिए.
Okay.
That is one difficulty which we understand when we want to use these. We try to use pomegranate, pomace over there, but उसमें particle size we were not able to reduce to that level.
No, डायरेक्ट सपोज अगर डायरेक्ट हम उसको एज अ रॉ यूज कर रहे हैं, नहीं उसका कुछ फर्दर सपोज ना जैसे कि शुगर कैन बैगास है, इससे सपोज करें कि हम सेलोज बना लें या फिर कुछ और अदर पार्ट उससे हम बना करके फिर उसके अंदर अगर हम कुछ ऐड करते हैं तो पार्टिकल साइज तो छोटा हो ही जाएगा हमारा.
छोटा हो जाएगा तो फिर प्रिंट कर लेंगे. कोई भी मटेरियल ले आओ, पार्टिकल साइज इज द ओनली कंसर्न फॉर अस. एंड वो सेमी सॉलिड, some powders no, they don't have that inherent cohesion properties with them. आप कुछ भी मिक्स करो सब अलग अलग ही रहेंगे, which is usually there in agricultural waste. उसमें एक कोहेसिव प्रॉपर्टी होना चाहिए which they will stick with one another among them. जैसे राइस फ्लोर इज हाईली कोहेसिव मटेरियल, वो मिक्स हो जाता है अपने आपस में. So that is the basic properties matters. So or otherwise you can add some starch to it, something to increase the cohesion properties. Maybe by percentage wise you can add your waste reuse material which you want to use. That can be done. Yes.
Okay, thank you.
Madam, good afternoon, madam.
Good afternoon.
My name is Tej. I work at a cancer institute in Jajjar.
Okay.
We have around 400 patients. I'm very new to this, but I found it very interesting. We have a lot of patients, head and neck cancer patients, who have dysphagia. So, what we try to do is we try to make a powder out of some nuts, which will be nutrient dense, and then we can give it through the Riles tube. Now the problem was that we could not fine grind it. The pulverizer was not grinding it properly. So when I listened to your lecture, I thought maybe we could do a semi-solid diet where we can introduce this through food printing, and then they can consume it. And then if there are any solutions that they can fine grind it, we can also deliver it as a liquid diet through the Riles tube. So what would your advice be?
Yes, for dysphagia, it's a proven positive technology over here. For dysphagia, we can use it obviously. And grinding, yes, we can find some solutions for grinding it and reducing the particle size of these dry fruits which you are talking about. Maybe wet grinding will work better in that. You can soak it overnight, because which you saw here, no, marzipan paste we are printing, that is basically only badam which is soaked overnight. We have an optimized formulation for that. Along with that gluey or that shining nature is coming from the sugar syrup. So if you don't want sugar for any reasons for the health of them, we can try to replace something with that. Maybe some hydrocolloids may also be replaced instead of sugar there. Yes, that can be done. That is theoretically possible.
Right, ma'am. The other question that I had was, you had mentioned that there is some agency in Bombay that Sugar and Space that makes these models.
Yes.
We are from a government sector where we have to purchase through this tendering process and all that. If I understood it right, if you buy a food printing system, the raw material that we have to buy will be a closed system. So they will define what raw materials the system will define and decide. So it'll be like a proprietary item list of those raw material items.
You
Is
are
that correct?
talking about the printer and the printable material, right?
Right, ma'am. The edible products which will go into the printing system.
Actually, as of now, we don't have an established system like this. Just like even FabForge we have purchased, they will not give me any material which they say that is printable. For demo also, they will bring some silicone gel and tell us ki this is printable. The problem is it is not in that commercial level. We told them, you are selling a food printer, at least print using some established Hummers or something and show us. That they are saying, ma'am, you give us something, we will get technology from you and we will do the demo from your technology. Matlab, it is at that level as of now, food printing, ki we don't have any established materials which you can say ki you purchase from the market, you print it. That is also one area which we are working on, where we are trying to work on frozen printable cartridges. We develop the cartridge, freeze it and sell it as a frozen product. So anyone who has a printer can get that frozen product, defreeze it or thaw it and then put it in the printer, print it. So that evolution is not available. If you get a printer even from some printers, they will not have a list of materials which can be printed by that, first thing. Second thing, even if they will say these already standardized printable materials, just like I'm saying you, hummus and normal jam or peanut butter, they will give this list, which we are not interested, or as an end user, you will not be interested in printing those products. So you have to research it and find out for your products whether that printer is printable or not. or you can collaborate with just like NIFTEM or some other institute, so that together we can find out, based on the requirement, we can develop some printable products. So that can be taken up as a project or some technology transfer. Based on your requirement, we will develop it, that one, and give it to you. You can then purchase a printer and use this as an ingredient. We will give you all the technology, how that is.
Ma'am, do you think bioprinting can replace vitamin supplement pills? For example, vitamin B12 for people who are strictly vegetarian. And which is a safer option, pills or bioprinted food?
And milk powder a bit, and give them that specific nutrition targeted product to them. That personalized component, yes, is possible.
second one was chocolate based snack. वो तो मतलब it is common वैसे भी, but something more nutrition based or something, क्योंकि
Yes,
kids
in chocolate also, that is one of the easily printable and a proven product for printing. So in that also you can incorporate some vitamin A or vitamin D or something over there, and maybe one child is vitamin A deficient, another child is vitamin D deficient. The parent can get one for vitamin A, one for vitamin D for the other kid.
Thank you, ma'am.
Thank you.
Ma'am, one another question.
Yes, sure.
How temperature and other processing things affect anti-nutritional properties of the millets?
You are asking a question out of syllabus for me, huh?
Ma'am,
Anti-nutritional tannins and phytins
yes,
and all
ma'am,
you are
phytates
talking
and
about. No, you have established methods for that, soaking, roasting, and all these things.
No, ma'am.
During printing, you are saying.
Yes, ma'am. I'm asking that during printing process, how antioxidant properties of the millets are affected.
Antioxidant properties. See, in printing, there are different types of printing. This topic I have not discussed. One is called cold extrusion printing, or other one room temperature extrusion, which is called RTE. That is room temperature extrusion. Another one is hot end extrusion is there. So if your product is good enough to be extruded at room temperature, you can just print it at room temperature. Whatever is the temperature, the heater head will not. Some printers don't have a heating head at all. You don't have to heat it at all. The printer which I work for my PhD does not have a heating head. So what temperature you give the product, at the same temperature it prints. So it has no role to play in affecting your antioxidant properties in any of the base raw material. Another one is high temperature extrusion, or where the printing head has a heater attached to it. You can switch it on or switch it off. It is under the control of the user. You can reach temperature up to 60, 70 degrees or 80 degrees max using that heating extrusion. Other than this, no heating, nothing happens during 3D printing. So if you keep the heater on, I don't think at 60, 70 and all, it will have any impact on your antioxidant properties. So in general, I would conclude safely that 3D printing will not affect the antioxidant properties as of basically of your raw material, since the temperature, it's not a high temperature processing, or it's not a high temperature operation.
Thank you, ma'am.
Hello, ma'am. I'm Akanksha Chaudhary, research scholar from the Department of Nutrition Biology. I just wanted to know from your perspective that how consumers are responding to 3D printed food. Are they seeing it as an innovation or something artificial?
There was a survey which was done and reported is there. Some people accepted it as a new texture, new shape, structure and all. Some people blanketly they denied the concept of why print food. It is there, both the ways are there, that perception varies from person to person. So you have this extreme also and that extreme also. So the report says that there are people that I don't remember exactly the output of that report, where what percentage accepted it and what percentage, but there was a quantifiable percentage who accepted printing as a new technology, some innovation where new shapes and structures are there. But there is also a set of population, I would say, who is not ready to see or not ready to even try printed food. So it is a walk on the rope only.
So it can be said that people are still neophobic to this technology.
Yes.
Okay, ma'am.
It will
Thank you.
take time because they have not seen it commercially anywhere. They are just hearing it for the first time, something like that. So when they see, taste it, see other people, peer perception also varies. When they see other people taking it, or things may change like that. That's all.
Thank you for the clarification, ma'am.
Anything else? So we'll continue here. So last 1 or 2 slides in this. So these are some of the printer bakery applications. In bakery, how they are printed, you can see bread is also printed in a heart shape. Otherwise, we always have printed a bread in a loaf or a square shape over here. Then we have appetizer cake. Some fortified cookies are used where bioactive plantain is used. These are other different bakery applications itself. These are 4D printing applications. We saw some of the color applications over there. Here some shape transformation is there. So with microwave heating is the stimulus applied there. So with microwave heating, the petals either they bend inward or outward based on the temperature application here. Then you can see potato starch is being used, which will this is in this shape. On application of that is drying, dehydration is the stimulus. On application, the shape changes. This is also shape transformation. For color transformation, we already saw 2-3 examples using bioactive materials over there. So this is some other color transformation application. And that's it about the different applications.
So thank you very much, ma'am. You have nicely explained all the concept of 3D printing, and you have taken some examples of 4D, 5D, and even 6D also. So I'm sure our students and the GIAN participants are benefited from this, and of course this is a novel area, new area, innovations are going on. So we all are excited for this new research, and you have shared some your practical experiences also on 3D printing, 4D printing, and even you have cited few examples of your NIFTEM products also. So with this, thank you very much for sparing your time and coming to this in-person program at the Central University of Haryana. And now I request Akanksha to do the felicitation of ma'am. Please, over. Thank you very much. Thank you. आकांक्षा कुछ बोलना?
Thank you so much, ma'am, for conducting such an engaging and insightful tutorial session. Your talk gave us a deeper understanding of how 3D bioprinting is shaping the future of food production, blending technology, creativity, and nutrition in remarkable ways. You have beautifully explained the fundamentals of 3D bioprinting and addressed every question with such clarity. I'm sure everyone here now has a much clearer understanding of this fascinating and futuristic field. We truly appreciate your time and effort in making such a complex topic so easy to grasp. With that, we now come to end of our morning sessions. It's time to take a well-deserved break and recharge ourselves for the next session, uh, for the next set of interesting lectures that are lined up for the day. Thank you so much. Enjoy your lunch. the field of nutrition and dietetics. Her innings in dietetics began at the Department of Dietetics at AIIMS, New Delhi. She then moved on to create and head the nutrition facility at PSRI Hospital, New Delhi. She has taught nutrition and health education at the University of Delhi for over 7 years. She has authored several books on nutrition titled Our Kid Eats Everything, Why Should I Eat Healthy? Indian Diet for IC, and also co-authored the book Fight Cancer with Flavor. Her weekly column Health in a Ball appeared in the Morning Standard, and her column Wait and Watch appeared in the Indian Express for many years. Her current column appears in the Pioneer as Mind Over Platter. She believes that eating right is the best investment for good health that anyone can make for the present and for the future. I now invite Nilanjana Singh to kindly begin the session and share their valuable insights with us through the online platform. A very warm welcome to you, ma'am.
Thank you, Akanksha, and thank you, Tejpalji, for making me part of this prestigious course. And the topic that you have given me is, it's actually a topic which I would say covers 4 parts. Can you see my first slide?
Yes, ma'am. Yes, ma'am.
Okay. I'm going to begin my lecture.
Yes, and
pick what you have
please share, ma'am, it on slideshow if possible, ma'am.
Uh, okay,
Yes, yes.
Is this all right?
Yes, ma'am, but I think your video is not coming in this case.
I don't know why I can't see myself, but doesn't
no issue,
matter.
no issue, ma'am. You can
I'll just continue, and you just have to, because I can't see you, so
okay,
I will just
so
have to
you
listen.
just yes, ma'am. So you can minimize this. Means you can exit this slideshow, ma'am. Then I think that okay, we can solve this.
If I exit it,
Slideshow only, slideshow.
yeah, I did the slide. If I stop sharing,
Yes, and then again start sharing, ma'am, please. Without slideshow, just we try.
can you see the second slide now?
I think, ma'am, first you have to download your Google slide on your system and then please share through your screen. So I think that work.
That I have already downloaded it.
Yes, ma'am. So at the below your screen, I'm sure you can see one icon just near to your video icon. That slide share icon. You just please click over there.
Okay.
अभी अपने पे ले लीजिए.
Hey. I think what I'll do is maybe start with the lecture in between, stop and see you all, if that is okay.
Yes, you can do, ma'am. No issues. And you can, we can see you, means we can see your video and you can continue. And we'll share the slides to our students or participant through the WhatsApp and all. Now we can see your slide, ma'am.
Okay. So
I think now, can you see us? Means
no, I can't see you.
Oh.
Doesn't matter. I think if you keep talking to me in between, I will be okay. I'll know that the other side is listening.
Okay, ma'am.
So long as you can see me and
so
you can
yes.
tell me in between if there's anything that needs to be done.
Okay, ma'am. So I think now you can try for slideshow because we can't see your screen, so better to have the slide. Yes, ma'am. So now it is fine, means we can see your slide perfectly, and
Can you
once
see
we'll
me also?
yes, video we can't see, but I think
Okay.
at a time we can see only either slide or either video. So no issues at all. We'll be in. We'll keep in touch with you. So if we require,
Okay,
we'll.
sure. So
Okay.
let
Yeah,
me
please.
start. So you
Yeah.
have Tejpalji, you've given me a very interesting topic because this covers actually 4 parts here, right into this topic, which is the part about the food and nutrition security. It is about the sustainability of millets on the planet. It is the health impact that it does on humans. And it's also about how to use millets in foods and food products. So you've given me a complex job, so I'll try and put it all together and give you a bird's eye view on this. So that there might be a little bit of overlap between the 4 dimensions that we are going to talk about, whether it is planet health, human health, the food products, and nutrition and food security, because what happens is it's all really linked together. We cannot think in silos anymore. So when we think about food security, we need something objective. We need to have an index to know where we stand. And that is why I'm just showing you one index. There are several ways you can measure it, but the Global Food Security Index has 4 dimensions to it. And you can see on the screen, the 4 dimensions are the affordability, availability, the quality and the safety of the diet, the sustainability and adaptation that it does on because of climate change becoming so important in this current era. So when we look at the index, the food security index, what we find in India, we score very well on the availability dimension. But in terms of the others, we are not so good, because of which the index that we have is not a great one. So what is really paradoxical is that we are self-sufficient and surplus in grains. We are the world's second largest producer of grains, and we export so much of agricultural products. And of course, these might change, the economics of it might change because of the tariffs, etc., that are being levied. But we are second largest producer of food grains. So we have so much surplus, we have great availability of grains. And on the other side, we also have great nutrition programs. There is no other huge program of nutrition anywhere as we have the ICDS program. We have the newer ones. ICDS is a very, very old program. And now we have the PM Poshan scheme and many other nutrition programs going on in our country. We have the National Food Security Act, which is an act of parliament in 2013 it was passed. So we have so many things in place, yet we don't fare well on the food security index. And that is because as I showed you in the previous slide, the 3 other dimensions, we are not very good at it. And one of the dimensions was sustainability and how we adapt to climate change. So we need to work on the other dimensions. We also, because of this not being so good on the food security index, we have the burden of malnutrition, hunger, poverty, poor health. We have a poor dietary diversity. We know that there is now very important index, which is the diet diversity score, which scores the diets, and we know how good the diets are. So our scores are not so good. It's easy to measure because you have to see how many food groups are there present in the diet. So diet diversity scores are not so good. So because of all this happening, it's time that we need to think about the next revolution. We had the green revolution in the 60s, and that gave us the bumper crops. But now we need to think a little differently because it's been 50 years and things have changed. So now we need to focus on different aspects, the sustainability, the diversification of the diet, and securing the farmers, because the climate crisis is really something that we have to be afraid of. We know that all over the world there is a lot of destruction happening, and it is actually very, very grave, the situation. And when the climate crisis is looming, we know that food systems will be affected, and we know that food systems account for the greenhouse gases emissions. One third of the human activity that happens, and one third of that, the greenhouse emissions, come from food systems. So we need to think along these lines. So we have bumper crops, that's fine, but that's not enough. And we need to think about the other aspects of food security so that we are good on the index. Just to give you a visual of what it could look like when there is climate change that is happening very rapidly, and it will affect food security in India and globally. When there is food and nutrition insecurity, we know that health outcomes will be bad. And we are looking at the NFHS 5 data, which is the latest data, 2019 to 21. We know that we have more than one third of less than 5 years who are stunted. There are huge number who are wasted. Wasting means there is acute malnutrition happening at that time. There is a huge underweight population, all this under 5 years. When we talk about children, these are grave figures. When we talk about anemia in women, that's really high. And it's not just the pregnant women, even the non-pregnant women are lacking in one micronutrient, and major micronutrient, whether it is iron, zinc, folate. All of this is very important um, for the woman herself, and if she goes into childbearing phase, it becomes even more grave. So any deficiency of micronutrient will affect the future generation. And these micronutrients are actually, one or more is lacking in more than one third of the global population. So that is how grave the micronutrient problem is. And we suffer from the triple burden of malnutrition, which is both over, under, and the micronutrient problem. So many times what is actually very, very grave is we have undernutrition. We also have overnutrition almost in similar numbers. So we have a lot of children who are overweight, and adults are also overweight and obese, and we have a huge diabetic population, which is 101 million Indians have diabetes, and the actual pre-diabetes who are actually at the fence and can turn into diabetics is also very high. So these overweight and obesity factors cause or leads the path to non-communicable diseases, and that is why it's not just a fashion problem. It's not just that we want people to lose weight for the sake of aesthetics. It is because of the risk for non-communicable diseases that it brings about. So we need to think about all these three problems that are happening in India at the same time, both undernutrition, overnutrition, and also the non-communicable diseases and the micronutrient deficiencies. This is the Eat Lancet report, which has just come out in 2025, which says that even although we have calorie sufficiency, there are 1 billion people on this planet who are undernourished. So clearly, just giving enough calories is not enough. And that is why I just want to say it again, because it's the micronutrients and also proteins which are being highlighted as very important factors in the diet. When we started out in the green revolution, we were more concerned about filling the stomach because we did not have enough food on our plate. In fact, the ships would come and get our food, and we would then be sort of feeding our population. But now it is different. Now both humanity and the planet, we are we are facing very demanding time because of the weather patterns which are changing, and these are not just changing, they are becoming very unpredictable, very severe. So because of this, we know that there are floods, there are droughts, and there are tornadoes. So all of this causes the agri-food system to crumble. And while this is crumbling, on the other hand, the food prices are soaring. So obviously, the purchasing power is going down, the population is growing, and the poor health results. When we try and look at it in this diagram, which I've taken from a paper which is recent, the annual reviews on nutrition in 2025. It gives beautifully how climate change and nutrition, how it is all linked. If you look at the figure, when you see on the left, the blue bar, when climate change happens, this is what happens is greenhouse gases are increasing, the global temperatures and the extremes increase, the sea level rises, and there is acidification of the ocean, and rainfall patterns are changed. We have seen it even in our cities. Everywhere the precipitation patterns, the rainfall patterns are changing. There could be floods, droughts, heat waves. Now we are expecting a cold wave in Delhi. So everything changes, and when these climate issues change, it affects the food system, it affects production of the food, the quality, quantity, the water. Obviously, when there are floods, droughts, water supply is affected, food, the production systems are affected, people have to move from one place to another. All of this causes effect on the food security, the diet, the health of the people. And because of the lower quantity of food that is produced, there's less availability, there will be stress on the families because of the economic stress, because of what they have to go through physically and mentally. There is stress, there are more pathogens, and obviously infectious diseases increase, and water supply is no longer safe. So what happens is there will be hunger, there will be more stunting, more wasting. We saw huge figures, 1/3 of our children. So all of this will only increase, micronutrient deficiencies will increase. And in the last three red bars, in the last two red bars, they have written obesity and non-communicable diseases, which are not totally proven, but these are impacts which are likely to happen. But the other hunger, stunting, wasting, micronutrient deficiency is definitely a proven impact of climate change on nutrition and disease. So immediate changes will be on hunger, the diets that you eat, and malnutrition will happen. And many projections have been made to study what will happen several years from now or sometime from now. So there are many studies and models. And one of these models is the food insecurity experience scale. This is just a model, and this suggests in this model that for every 1 degree rise in temperature, that happens, the FIES score that's on that scale will increase by 2.1, and this will impact what? This will impact the food production. And so the projections that have been made, and this is, I've just used many different studies, and in 2050, the different studies, the different pathways that they have used to study different models, they show that they will be decreased global production by 6%, 10%, 14%. I didn't want to talk about all those models, but just to tell you that ranging from 6% to 14%, there will be decrease in global production. And obviously, when there less food is produced, there will be more food insecurity. And these are some of the figures that they have mentioned in their models, that can be as high as 1.36 billion people can suffer from severe food insecurity. And according to the FAO, the climate change is one of the leading factors for people who will go undernourished and hungry. So definitely this is some aspect which is connected with diets very strongly, and we have to think along those lines. So when I showed you those 4 bars, we know that climate change, changes in weather will affect diet and nutrition. So we cannot think in silos. We cannot just sit back and think that things are not interconnected. We generally tend to do this. Like if I am a dietitian and I'm prescribing diets, I also need to think about what kind, obviously the therapeutic value of the diet is important, but we also need to think in terms of agriculture and food production. We also need to think about the consumption patterns. So when I say agriculture and food production, we have to maybe prescribe the micronutrient rich staples versus the ones which are not that rich. When we talk about consumption patterns, we know that there are many programs which help in changing the consumption patterns, and there are many nutrition programs where even in the Anganwadis, people are taught how to make certain snacks, they are fed those things, community kitchen gardens are there, so that helps in changing the consumption pattern. And of course, something that I have to do regularly is nutrition education. So if you tell somebody to eat a particular thing, you have to also educate them as to why you have to do that. You cannot just say, eat this. You have to give the entire background, and nutrition education is something that is also connected with behavior change. We know that if I tell you, if you're eating rice and you're fond of rice, if I suddenly tell you to eat millets, it probably will not happen, because we are resistant to change as it is humans, and we also don't like to change behavior that quickly. So nutrition education is linked to behavior change as well. So it should be done in a particular fashion so that it is more acceptable. This again, I took from the same paper in the annual reviews of nutrition in 2025, which again, when you see on the screen, in between, at the center of everything is climate and nutritional resilience. And how do you have this resilience? How do you bounce back? How do you bounce back when there is climate change, climate issues? You can do it only by a multi-sectorial approach. And I am just going to focus on food because that's my area. When we talk about resilience through food, as you can see what is written here, you have to invest in improved agroecological techniques and increase the production of nutrient rich foods. So that is, of course, there are other aspects which you can read later and think about it, dwell on it. But this is one very important part of the resilience, how we can deal with extreme weather events and how we can ensure food security and safety through the ecologically adept agro techniques which are safe and sustainable. So that is the most important part, and of course the other parts are also important, but because of the issue of time, we cannot discuss all of that. So we need to talk about these techniques which can increase production of nutrient-rich foods. So we need to think about agro, ecology, and nutrition all together. And we know that food systems, like I said, is the cause for a lot of greenhouse gases that are emitted. So we need to shift this, do our best to reduce this. And how do we do it? By climate smart agricultural practices and encouraging R&D in this area. And one of the very important things which is being done is to think about drought resistant crops. We need to diversify our crops. We need to promote crops that are bred for high levels of micronutrients. And we need to think in terms of traditional crops and diets also. And the traditional crops have also been mentioned as a very important part in the Eat Lancet Commission report in 2025, which has come out recently. So we need to think about these particular ways so that we are able to stabilize our food production, have enough buffer to be resilient against any climate shock. So when we talk about all of this, the central theme is millets, because here millets lie at the center of climate resilience. It lies at the center of livelihoods for climate for farmers, and it is a great crop providing high levels of micronutrients, and also it can be fortified very well. So all of this is possible through millets, and that is why we have millets at the center of all the three aspects. So when we talk about millets, it's important that we know why we are talking about it, because we have just 4% of the water resources of the world, and we have a huge population, 15% of the world's population. So these traditional crops like millets, they are nutrient dense, they are better adapted to the environmental stresses. And as you can see in this paper, that Carducci in 2023 has said that this is when we produce these nutrient dense and climate resistant resilient cereals, we have a good food basket for all. When we talk about traditional crops, we think about millets because we have evidence, historical evidence of millets being part of our diet for many, many years. And this is based on evidence. It's not based on hearsay, but it's based on evidence, because we have had this long cultivation history, and the sites that have been excavated, the Mohenjo-daro and the Harappa sites, have found traces of millets there. Of course, our scriptures also mention millets in it. Of course, they might come under different names, but millet intake has been recorded even before the Bronze Age, which is 4,500 BC. So there is evidence for that. There is record. Taylor Singh, who's a very well-known food historian, talks about how in Jahangir's diet there is bajra khichdi mentioned, where millets are boiled with split peas, and so we know that there is archaeological evidence, there are scriptures that mention it, and there are food historians which are recording that millets have been a traditional crop in India, and it is something that we need to sort of go back to. But what has happened is, although we were eating millets in those times and as long back as the Bronze Age, but what happened? The food landscape changed because what happened was the Green Revolution here. In the Green Revolution, like I said, the idea was to boost the food production, especially the staples. And at that time, millets accounted for a huge percentage of the grains. But now it has come down because when the Green Revolution happened, different crops were promoted. Mainly it was rice and wheat, and these crops were given incentives and subsidies so that they were grown faster and they were available for the people to eat. And what happened is when people started eating this, they were easier to use, they cooked faster, there was no need to soak, no need to go through several processes. So people took to it and they changed their dietary patterns. And what is happening now? We are eating a lot of these cereals which are calorie rich, and then it is proposed that many of the chronic diseases, it lays the path for many of the non-communicable chronic diseases like diabetes, cardiovascular disease, etc. So it changed after the Green Revolution because at that point of time, the objective was different, and people found, when we find something easier, what I have seen is even when you tell people to eat something, it's always easy to tell them to eat something that they can swallow faster, don't have to chew. So we have become like that. We are always seem to be in a hurry, and that is why many of the programs for healthy eating tell you to eat slowly, chew your food, and we need to make sure that whatever food that we eat needs to be chewed. Many times what we are eating is so soft that we don't need to chew it. And then we need to think that is this the right food for us? This is a very important study and it has been out very recently. So I thought I should mention it, that this is very clear that the changing eating habits are fueling obesity and diabetes, which has been shown through the ICMR and Dr. V. Mohan, who is a leading authority, that how we are eating is causing this. So that is pretty clear in this ICMR study. We'll go into a little detail very soon. When I look at the plates right now, whether it is rural India or urban India, so the plates seem to be full mostly. And when we sort of analyze the nutrition, it is not really good. So plates can be full yet empty of micronutrients. They could be protein lacking in it and many other aspects. So it's not enough to have plates that are full. So it is more about the quality of the diet also as important as having the plates full. So I'm a great believer in making investments in your diet, and it is your bank account. So when you make the right food choices, you make good investments. Some investments are very short term, some are long term, some are very long term. So when you make the right food choices, you may not see immediate returns. So it's not like the stock market where you play and you get immediate returns, but it's a very good investment, and it's not that also that far that you have to wait. You can see even now there are many studies which show how food choices change your mood, how they lead to depression, anxiety, all of that. So when you make the right food choices, you make good investments. And one of those good investments is by eating millets, because it's central. Not only is it good for you, like I said early in the lecture when I started, that this lecture has 4 parts. So we talk about food and nutrition security. We also talk about planet sustainability. We talk about human health impact. So all of this is possible through millets, and that is why the government has given, not just our government, the international initiatives for millet has been active since, I would say, 2012. There is a lot of work that has been happening, but again, I'm repeating it, that changes in food and eating behavior takes a lot of time. So that is why we are still working on it. And I would say it started in 2012, where I mentioned that the National uh, Nutritional Security Act happened, and there was this initiative to include the coarse grain. This was in 2013. Then in 2017, the NITI Aayog released the National Nutrition Strategy for Nourishing India. Here again, emphasis on millets. In 2018, it was declared as Nutri cereal because of the nutrition that is available there. They were officially, the millets were declared as Nutri cereals. They were made part of the National Food Security Mission, and it was declared as the National Year of Millets. And then it has gone on in 2022. The production linked incentive plan was given so that the people were encouraged to produce more millets, the companies to manufacture more millet based food products. So this happened in 2022 and 2023. The International Year of Millets was celebrated, and there was lot of activity in terms of government schemes, and even at local levels, a lot of initiatives to promote millets was there. But the government initiative comes first, because that can happen very fast. Once you have a government being interested in a particular field, things work much easier. So that happened, and in 2023, it was the International Year of the Millets. It was declared that. We also know that the Sustainable Development Goals and millets are very well aligned, and we have all these goals that I have mentioned here. The goal number 2, which is the food security and nutrition goal, the 3, which is making a part of your overall health and well-being by making a part of your regular diet. So all of this, whether it is for the farmers, the goal number 8, whether it is the environment friendly attribute that it has, or whether it is the holistic way to promote biodiversity, which is goal 15. So millets are aligned to so many of these sustainable development goals, and we can see that it fits in very well into the scheme of sustainable development. So there are so many reasons to uh, get going with millets. And obviously, you are aware of major millets and the minor millets, but I just want to tell you, major millets, the name comes because they are grown over larger land, and the grains are also larger. So that is why they are called the major millets. The minor millets, the seeds are smaller, and they are not grown that extensively. And pseudo millets, because they are not really millets, but we still use them as millets because they are very rich in nutrition. So we look at this as the complete picture of millets, and we try and promote different food items made out of these millets. Just to give you a snapshot, because each millet has to look different. It has its unique characteristic, whether it is ragi, the finger millet, you can see in the picture because it's fascinating to see how different they look. I thought I'll just put a picture to show you how they look. And you can see it has such a good content of whether it is protein or whether it's fiber. And if you compare all of this, whether it is the calcium, iron, all of this is much higher than what the staples we mostly eat, which is rice and wheat. And when you look at it, the foxtail millet, when you look what's written there, it is even good in calories. So many of these programs where you want to give a little calorie dense food and when you want to give something that looks exquisite, even it's a very good substitute for quinoa. Quinoa is quite expensive, but it can be a very good indigenous substitute for quinoa. There are a lot of stores selling quinoa flour. So here I wanted to mention that this is a very good substitute for quinoa. And all of these have great great quantities of protein, fiber, carbohydrate, calcium, iron, and there is no gluten that you can see here. I think talking about gluten, I'll come back to gluten in maybe a couple of minutes, but there is no gluten, which can be an advantage or disadvantage. So although there is no gluten, I would think that it's the other parts that we need to focus on. And everybody doesn't need to go on a gluten-free diet. Gluten-free diet is needed by some people, but it's become more of a fad and people just want to have gluten-free diets because they think it's meant for everything, right? From weight loss to any problem, they want to go off gluten. But that is not required, but all these millets remain gluten-free. So just to tell you that the nutrient profile is excellent, and in the protein, foxtail millet has the highest. In the fiber, ragi has the highest percentage. In the PUFA segment, bajra is great. Calcium, ragi is very, very good. And that is why a lot of products for children are being made with ragi. It has 10 times more than the other staples. The bajra content for iron is great. But besides all of this, we know that millet is a functional food. And what is a functional food? Which gives health benefit that is proven beyond their nutritional value. So we know that the calcium will be great for bones. We know the iron will be great for your blood work, but there are benefits beyond what you see as the nutritional value. That is why millet is called a functional food. And where does this come from? This comes from all the phytochemicals that are present, which give the therapeutic effect, which are the polyphenols, the phenolic compounds. But I just want to mention here that millets are great in terms of nutrients. They have these phytochemicals. They can be called functional fruits because they have great nutritional value. But we have to make sure that these are minimally processed millets that we use. If we process them so much that we lose all the benefit from there, then the millet cannot do anything. So when we are choosing products, we should make sure the millets will need processing. You can't just get the millets out of the field and eat it. So obviously they need processing, but the processing should be just enough to get rid of the anti-nutrients and better digestibility, but we need all those phytochemicals there. So millets can be a game changer in this scenario where the climate crisis is looming, where we have hunger, obesity, all of that happening at the same time because of the great nutrient profile. the bioactive compounds that are there, and it gives protection from many of these NCDs. And these are studies which you will find many studies where it is protective, whether it is type 2 diabetes, high blood pressure, and Parkinson's disease. So these are studies which you will find that it shows that when you have millets, these offer some protection. So this was a 2023 study where it shows that it helps in combating non-communicable diseases, and it is something that we need to promote in terms of growing more millets and cultivating our health. When we talk about type 2 diabetes, pre-diabetes, let's see what the evidence shows. The systematic reviews and the meta-analysis of 38 studies show that these millet diets, and millet diet means you have to take a regular intake and lower fasting blood sugar, postprandial blood sugar, and hemoglobin A1C. These are 38 studies, the meta-analysis. Even in gestational diabetes, a pilot study in 2024 showed that if you have millets once in a day, it improved glycemic control versus other low glycemic index foods. So it's not that it was compared with high glycemic index foods. Other low glycemic index foods were compared, and what was shown is that millets are helpful in achieving glycemic control, because millets release the glucose over a period of time, and many of the micronutrients that are present in it also help in this process. So the glycemic index is low for millets, but the way they are processed can change that. And what else can change the glycemic index? When you add it to some other foods. If you add millets to, say, a sugary syrup, that will change the food matrix. And how you use the grain, is it super processed? Is it processed very, very refined? So all of this matters. So when you say millets, you need to know how that millet has been processed and what is the form that is available in that product. So it is helpful when you take it regularly and when you use it in the right way in terms of using it in the right food matrix. That is important. But here again, I come back to the ICMR study, which says that the carb dependence is pushing us to diabetes. So although I have talked about millets and how it is helpful in preventing NCDs and how it is so nutrient rich, but I want you to pay attention that it is not that if you don't worry about the full plate and the millets get skewed in terms of, if, as you can see on the screen, if the fiber rich millets is right now 1/4 of the plate, if that changes to become half of the plate, obviously there will be a skewed reaction, metabolic reaction. So we need to take the plate in totality, and what you can do is swap what is required in terms of the carbohydrate, the requirement for carbohydrate, swap that with millets. But you cannot misconstrue. You cannot say that because millets are helpful in preventing non-communicable diseases, you can eat more millets. So it is about the balance. Here in this study, this ICMR study, what was noticed is Indians were having 65% or more of carbs. So if you have that huge amount of carbohydrate, when you should be eating about 45%, you're taking 65% of carb. So if you take 65 and you eat millets, probably it's not going to help. So what you need to do is stay within that framework of a balanced diet that is recommended and switch from the low fiber, low micronutrient cereals to millets, which is rich in all of this, whether it is calcium, iron, zinc, fiber, protein, all of that. So remember the plate and the swapping should be within that framework of a balanced diet. So it cannot exceed that. And then you expect that millets will do some magic. That will not happen. There is enough data also to show that it is helpful. Millets are helpful in reducing the low density, the LDL levels, the LDL cholesterol, low density lipoprotein cholesterol, the VLDL cholesterol, the triglyceride, and it helps to increase the good cholesterol, which is the HDL cholesterol. And this is a study which is done by Anita et al., which shows that obesity and hyperlipidemia was managed more effectively with these millets. Today, we know that the gut microbiome is very, very important in our health. Almost 25 diseases have been linked to how the gut microbiome is in that diseases have been linked to the skewed gut microbiome. And here, studies on millets have shown that the beneficial microbiota is sort of, it is helpful to make sure that these beneficial microbiota thrive in the gut. Because what do the gut microbiota, the lactobacilli and the bifidobacteria, which the species which are helpful for human health, these want more fiber, and that is available in the millets. And that is why there is alteration in a beneficial way in the gut microbiome, and many studies have been done to show this benefit that comes with millets. And there are different aspects of the gut which have been studied, whether it is the motility or the balance of the bacteria. We don't want to drive out all the bad bacteria, but we want the good bacteria to be in abundance. Just like when we have an opposition, we want a little bit of an opposition, but we don't want that it gets wiped out. We want that the good bacteria should be in plenty to do the good work. I talked about the phenolic compounds that are present in millets, and that is helpful in also preventing DNA damage. This is a study done by the researchers from Chandigarh University, and they show that there is protection against DNA damage. When we talk about millets, we have to talk about children and what it does for our children, and feeding a millet-based diet can improve the growth of the children. This was done as a systematic review and meta-analysis, and what was shown in this study was that there is, when you have these millets as a part of the food basket, there is definitely significant nutrition and health benefits, and it also helps to lower some of the cholesterol levels which are bad, and helps to deal with the iron deficiency. So it is again a very good investment that we can make in the diets of children. When we talk about children, we need to have millets in school feeding programs, because that way you can reach to the children who are underprivileged, and also when they eat in schools, they are able to accept things more easily. Of course, in Karnataka and in the peri-urban areas, millets are more acceptable. But in Delhi and Delhi school programs, we have to make the millets a little fancy for them to accept it, but it was accepted in school programs. Like you can see in this study, there was improvement in stunting, and the BMI also improved when millets were part of the school feeding program. And I want to say that when we want children to accept things, We have to make it fun for them. And of course, school feeding program can be one way of introducing millets, but there can be many other different ways. And in the more elite schools, there are millet chefs and they do many kinds of programs with millets, but that is more exclusive. But when we want to reach to larger numbers, the school feeding program is a very good way of teaching children to make sure that there is better acceptability. But while I talk about all this as great attributes of millets, I want to say that millet has its challenges. It's not that it does not have challenges. Every plant wants to defend itself, and it has defense mechanisms there, which is structurally it's present, and I think all of you must be well versed with it, that there are physical barriers which we remove when we process a grain. There are also chemical barriers, and every plant has their unique barrier. And whether it is spices, sometimes we find that they are bitter. We have the green part of the potato, which is solanine, which we remove. So we have chemicals which are present, and we have structural barriers for plants. So there are inhibitions and there are inhibitors which we have to make sure that we deal with them, and we make sure that by using processes like germination, cooking, fermentation, we are able to reduce these enzyme inhibitors which are present in the grain, in the millets, and we have to process it in a way that we are able to overcome them. So there are many critical steps in processing, and the first important thing is soaking is very important in millets, because when you soak, the plants think that now it's time to let down the guard, and the anti-nutrients begin to break down. So activation of the enzymes also happens, and the fiber gets softened up. So soaking of millets is a very important step. We have soaking also for other foods like legumes also. Soaking, we make sure that we soak the grain so that we don't deal with too much flatulence and gas, because each plant, like I said, each grain has its own defense mechanisms, and we have to, when we have to eat it, we have to make sure we deal with that. Fermentation is a great way to overcome these, but many of the food processors are dealing with the inhibitors in different methods, but many traditional recipes use fermentation. And as you know, fermentation is a longer process, but it helps to reduce the phytic acid, but it improves the iron and zinc availability. So there are some fermented drinks, and now you know that fermented food products have again become very sought after, and there are many new varieties of fermented food products which are available. But what I noticed, and Tejpal ji can correct me if I'm wrong, many of the food products that are available today made from millets, most of them don't use fermentation as a regular process, but some of them do. Most of them use other methods so that they are able to deal with the anti-nutrients. So processing can be many steps, and it can be a combination of these. So I've just mentioned, like, you start with removing the husk, then soaking, and it could be a combination, like some of the companies just soak and then they roast it and then they germinate. Germination can be after soaking. So it's not like, this is not a serial wise process, because one doesn't have to go through all these processes. So it could be a combination of this depending on what is the product that you're wanting to make. and you can see the different processes that are used for millets. And many food products just use, say, they soak it and then they germinate it and then they roast it and grind it, and then they have good products which does not have the anti-nutrients. This will give you a this paper will give you a comprehensive review of the anti-nutrients in millets. And this paper talks about thermal and the non-thermal reducing techniques. So some of the non-thermal techniques are new and they have been used and they have been also discussed in this paper. We know the traditional way of dealing with anti-nutrients was soaking, roasting, fermentation, germination. But in these novel techniques, the thermal one is ohmic heating, and this is done with electrodes so that the grain does not really get hampered because of the heating, and non-thermal heating, which is the ultrasound techniques that are being used to deal with the anti-nutrients. And these papers by these researchers have shown that the anti-nutrients can decrease because of these hydrothermal treatments, and whether it is tannins or phytates, and whether it is in finger millets and pearl millets, these were the ones that were studied. There was better nutritional availability and making them more complete and a beneficial food source. So we have to deal with the anti-nutrients. This is one of the challenges, but once you deal with it and the novel techniques can be used, and that way you have better availability, because we want as much nutrition from them. We don't want to waste any of the nutrition that is available. So this will become a better food source. So processing becomes very important, and using the right technique can help deal with undernutrition, because if you have better availability of iron, zinc, calcium, it will help deal with a micronutrient deficiency problem, because availability will be better. But we also have to make sure that the processing does not remove too many things, because if it removes too many nutrients, one, the GI of the millets will become higher, the glycemic index, if you remove too much of the fiber. So we have to be watchful, because if you look up Amazon or any of these platforms which are selling food products, what we realize is there's plenty of millet-based foods that are available. So you have to distinguish between the good and not so good products. So when you're looking for grain flour, so if you're looking for jowar flour or you're looking for any of the millet flours, what you need to do is you have to make sure that if the packet says 100% whole grain, so whatever the grain is, whether it is jowar, bajra, ragi, if it's 100% whole grain, that will be good. If you're taking the full grain, make sure they are unpolished grain, because the seed food is rich in polyphenols, so we don't want polishing to happen and the seed food to be removed. So millets can also become ultra processed food. So there is that danger. And like I told you that once you put millets into a food matrix, which is say too much fat or too much sugar, so how you combine millets and making it an ultra processed food will actually be very negating the whole purpose of using millets. So how you combine millets, what are the foods that you can prepare out of it to make it beneficial becomes important. Because this has become very trendy, baking with millets. And if you go to the internet, you'll see many recipes. I just saw this recipe and I thought this looks really simple, because it says one ingredient recipe, because it just uses buckwheat. and here it says you make buckwheat bread and you soak it and use it to make bread. But this will not come out as fluffy and as good as one would expect. So I just want to tell you that because there is no gluten in millets, baking is not that easy and you need alternatives to bind the bread. Otherwise, your bread will crumble. And I face this issue with lot of breads that are gluten free. Children don't want to eat it. Those who have celiac disease have to eat gluten free bread. But that gluten free bread is so dry and crumbly because gluten is the binder. So whenever you have to do baking with millets, you need something to bind it, to hold the bread together. Sometimes they use a protein source, whether it's egg or soya, and whether it is xanthan gum, guar gum, pectin, something to hold the bread to make it tasty. Otherwise, you can bake bread, but it will not be something that's acceptable. You can't force children to eat something that is so dry, crumbly, and not so tasty. And of course, right now, gluten free breads are very expensive as compared to regular bread. So that is also a challenge because baking is a little tough with making gluten free bread, and it does not keep for long. But it is possible with newer recipes, etc., to make gluten free bread and also bring down the price. So over time, this will happen. So when we talk about um, making food acceptable and also something that uh, people will like to have, we have to make sure that the education is right about millets. So sometimes people think that you have millets, say once in a while, and that will bring about the health benefits. No, that does not happen because it's been seen that you need to consume it daily over a period of 6 to 8 weeks to get the benefits of whether it is lowering cholesterol or improve gut microbiota, anything that you want as a benefit, you have to take over a period of 6 to 8 weeks. Another very important point which I often find is people become enthusiastic about having millets, and what they do is substitute the entire rice or wheat with millets all of a sudden, and that can cause a lot of bloating and digestibility issues. So it's better to go gradually, get your gut microbiota sort of accustomed to it. So start with just 33% of your total cereal intake. So combine the other flours and get millets into your diet, but do it gradually because of the fiber there can be a lot of bloating, and what happens is then people say that oh, millets don't suit me and I will stop eating millets. So if you don't go head on, go about it gradually. The other thing is people are not very acceptable to the colors because it's a darker color and the taste is different. So like I said, you have to do it gradually, and you don't have to, on day one, substitute your entire cereal intake with millet. So do it gradually. That way, acceptability is better. And once you get accustomed to your palate gets accustomed to the taste, it will better acceptable. And very often, people are worried that millets can increase goiter risk. There's no evidence for that, and people think that it can't be taken in the summer months because it produces a lot of heat. There is again no evidence for that, but there is some individual variation. Sometimes people react to foods differently, so it is better when you are introducing millets to go about it gradually. There are many kinds of millets. Like I said, all the platforms which are selling food. There are a whole lot of products that are available, whether it is in the rava form or porridge form, or flakes, pasta, pancakes, noodles, all these food items are available. A lot of bakery products are also available. Like I said, initially, say 10 years ago, baking with millets was a challenge, but now you have a lot of bakery products also available. This is this just as a sample that go for the unpolished grains, which says on the packet itself that these are unpolished grains. So choose those over the polished grains. And while we are talking about millets and we are talking about how to introduce them and we want to introduce them for children, I want to mention that there are a lot of snacks items available for children with millets. But again, think of the food matrix. Look at the product in terms of what is the label saying. Because if it has some things which are just not suited or not recommended, and just having millets there as a small percentage may not be good enough. This is something that I want you to sort of dwell on, because this ICMR survey showed that India's obesity problem is becoming big, and many of these companies are sitting on boards for policy making, for choosing what public health issues we will tackle. So when we have snacks which come into the market where the food companies are also on board. So this is something that is problematic, and that is why we need to be careful when we choose these snacks for children, because there are a lot of these snacks which are not so healthy, and just having millets as one of the items may not be good enough. So when we look at a snack, whether it is something that looks attractive, but we need to go into the details and see what's in there, whether the flour is of the kind which is not refined to a great degree, how much sugar is there, because most food items will have sugar, honey. So I'm just talking about just as a sample. This is something that I use myself, so I thought I'll show you these products. They don't use a lot of sugar. They use a little bit of date sugar, and they use natural products so that children don't get the wrong foods along with millets. So when you have millets in a form that gives you the nutrition, gives you a little bit of taste, it may not be as nice as a pancake made out of maida, but it is comparable, and children will get accustomed to the taste, because it does have a little bit of jaggery, or it has a little date sugar in it, but excessive amounts are definitely not recommended with millets. Traditional food items that have been around have therapeutic curative values, but they have very high ratios of fiber. So it's not something that everybody should have, because these are given for particular purposes. There are special recipes. Even one would think that millets are just part of, say, Maharashtra or Karnataka and the southern part of India, but I was looking at this recipe, which is from Eat Right India Thali, this book. And in the north region, a special millet recipe from Jammu and Kashmir is also there, which is part of the Kashmiri cuisine. So I was quite surprised to see it there in this book as coming from Jammu and Kashmir, because a lot of focus is just recipes from the southern states. There's a lot of work going on in NIFTIM to develop products which are innovative, that are acceptable to the public, and also tasty. And as you can see in this picture, they are no added colors and flavors. They are rich in micronutrients, and they look quite tasty. I haven't tasted it, but obviously these are foods which have been tested, and I'm sure that these are foods which will provide the nutrition and also be acceptable to children and adults as snacks. Snacks are so important for us, so having the right kind of snacks available becomes quite a challenge. And when you have this millet snacks which are not overly processed, do not have a whole lot of sugar and fat in it, these are actually a boon. And we have many products coming out of Niftim, and hopefully we will be able to propagate many of these into our daily lives. Innovative menus have become quite fashionable in terms of they are available at exquisite places. Like you can see millet pina colada. This is a drink which has dry roasted foxtail millets and sattu jawar sharbat. Sattu, we know that sattu can be made out of jawar. It can be made out of other millets as well. So these are all millet recipes. So it's possible to make many things out of millets, but the important part is go for maybe the grains which are unpolished and then process it, or if you're taking the flour, make sure that it's not super refined. So right from desserts to starters to even millets added to non-vegetarian foods, it's possible. So I have been promoting millets for a very long time, and as you can see, some of these are very old. 2019, in 2000 itself, I've been writing about millets. But like I said, that just one person or some people talking about is not enough, and we need to have the government supporting production, consumption, all of that. So we need to change the policy. We have the science, and we need to put it into action. We need to have very clear messaging, whether it is from the point of view of our health, from the point of economics or soil, environment. We need to change perception of the farmers, of the consumers, and health professionals and corporates can play a big role in this. But the policy change is the most important. There should be enough funds and incentives for people to grow millets, and including it in the PDS, the public distribution system, which is happening now, making sure that farmers make a profit from it, a decent profit, is very important. And we have to make sure that at all the stages, the farmers are supported, whether it is for storage, procurement, production, all of that, so that there is incentive to grow this, and the entrepreneur who wants to process this grain is also encouraged. And there have been many moves which the government is doing, whether it is reducing GST that was done in 2023. Now it's also included in the PDS in some part, but it's not really that acceptable. So we have to work on getting the consumer acceptability also there. So sometimes I feel that although millets was earlier poor man's grain, but no longer, many of these products are very, very expensive. So in the PDS, the availability and acceptability is something we need to work on. So we know that there are many positives that come from the millet, whether it is the nutrition, and what we also know is that biofortification, that is when millet varieties are grown with higher content of iron, zinc, that is also possible, and we should try and make sure that these biofortified varieties of millets, Dhana Shakti is one of them, pearl millet has been fortified, biofortified, so it's something that will benefit us. the supplementary nutrition program should have more of the millets in their menus, and of course the support price for that should be maintained. There is definitely a change, and right now it's good, but we cannot let it down. We have to keep working at it. And the government also needs to support, because there is special machinery which is needed to process millets. It's a very hard pericarp, so we need special machinery, and it has a lower shelf life because the lipase activity is very high in the grain. So infrastructure for storage also. We don't want to waste whatever we produce. So challenges are there, whether it is pre-harvest. Many of the farmers are reusing the seeds from the earlier harvest. So then there is low yield. So we have to make sure that the cost of the fresh seeds are not very high. So the post-harvest challenges also, like I said, they are the storage is important, infrastructure is important, and collection centers should be a facility which the farmers should be able to avail of. So millet is very powerful, and most importantly, it has the power to give us food sovereignty. That is the right of the people to healthy, culturally appropriate food through ecologically sound and sustainable methods. So it gives us that power, which I think is the very important thing, and it can transform our agri-food systems. It has a short duration, and multiple cropping is possible, and diversity in our food grains. Climate change, it grows on very arid soil, doesn't need that much water. It is very water efficient, energy efficient as when compared to rice. You can see the figures here, the lower rates of water that is needed, and it has zero carbon footprint. And most importantly, it has the power to eliminate hunger, because in this era where climate crisis is looming on us. So it is time that we talk about one health approach. And one health approach is where we think about human and environmental health in one as one aspect. So we need to have these locally grown foods, and we we know that for human health, we majorly need plant-based diets. We have to reduce food wastage, and behavior change is needed to accept it after years and years of eating softer grains which don't need chewing. We need to have behavior change strategies so that we are able to accept more of millets into our diet, because it's not only good for us, it's good for our climate, it will take less of our resources and great for the farmers. So I would say we need the 5 Ps. We have to boost the production. We have to make sure the procurement takes place locally, the processing facilities are there, pricing becomes important, and public distribution system should be able to dispense of this. So it's just coming to the end. Millets are climate resilient, and the fertility of the soils are going down. We have dry land, so this is the ideal crop. We can adapt to the environment, and we don't need to offer them that much fertilizer or pesticides, and we use less water, less energy in processing. They are very hardy, and this is what we are looking for, a grain that can sustain us in these extreme conditions of weather. You can get a lot of information on millets, any aspects of millet, but what I want to tell you is we have to somehow, each in our own way, and all of you who are students here can play a big role in promoting millets, not just for human health, but for environmental health. So thank you so much for listening to me, and
Thank
Thank you, ma'am. Thank you so much. So at this point of time, I hope you can see us.
I'm trying. Yeah, now
Yeah.
I can.
Okay.
Finally, I was drawing a blank and I could not see the audience, which is not a great feeling, but I somehow managed that.
Yes, ma'am. So wonderful, ma'am. You have nicely explained the therapeutic benefit of millet cultivation, then strategies, and you have aligned your lecture with the policies also. So, with your permission, ma'am, some students would like to ask some questions. So,
Sure.
if it is okay, then we'll allow them.
Yes,
Thank you.
sure, please.
Thank you.
So, very good afternoon, ma'am. Myself, Jyoti. So, ma'am, I would like to know how upcoming dietitians can help in tackling the non-communicable disease that are growing so fast. How they can be the link between, like the problem, government, and as a dietitian or as a upcoming nutritionist, how these people can help.
Yeah. So, dietitians could be working in different capacities. If you're talking about a dietitian who is actually her whose role is to disseminate knowledge in the community, that of course is different. You have to tell people how to use the millets, because when you are in on the ground in the community, you have to talk in the same way as they understand. And when you're sitting in a clinic dealing with maybe the urban elite, it is a different way of explaining to them. But what I want to emphasize is you have to tell them as a dietitian that millets can be swapped for other cereals and they give a lot of benefit. But just eating millets and not paying attention to the rest of the food groups and not having enough protein in the diet will actually negate whatever benefit that millets will do for you. So, comprehensively, you have to talk about the full diet, where substitution is a great idea, making sure that there is enough fiber in the millets, choosing those millets which those brands or those flours or those grains which have not been polished and still retain many of those nutrients. So think along the plate, and millets can be part of the plate, but don't skew your advice or don't imbalance your advice. That is what I would like to say.
Another thing, ma'am, like educated people also used to visit doctor as compared to like to tackle their non-communicable disease better. They should change their lifestyle along with the medication. But it's very less in India that they go to dietitian or as a went to nutritionist. So how we can tackle or aware people about this?
Yeah, that's a very good question, because it's true that the awareness about how the NCDs can be tackled by just changing your lifestyle, that was not there. But I think it's growing, and it's also the responsibility of the medical professional. Like when the person comes to you with a problem to the doctor, they should refer those cases to a dietitian, because it's not that the first thing they need to give is a drug. The first thing that needs to be done is to change the lifestyle, the diet, the activity level, the sleep patterns, all of that is important. So if a reference is given for a dietitian, so that awareness should also be there with the medical community, who can give that importance to the dietitian and refer patients.
Ma'am, there are many diseases, non-communicable diseases that can be tackled by changing lifestyle and diet. Still,
Yes.
they are relying on medication like diabetes. It's the most common. Obesity in children's nowadays, it's growing.
You know why why people don't want to do changes in the diet. Of course, we are resistant to change. That is there. But also, it's not a magic. अगर आप एक drug ले लोगे जो पैंटोसिल लेते हो एसिडिटी कम हो जाती है तो drugs and diet में ये फर्क है that diet is not a short term investment, it's a longer term. तो आप एकदम magical ये इफेक्ट नहीं देखते हैं. So people think you have to work harder, you have to work longer. So I think what we need to do is make that thing very attractive for people to follow. It should not be कि अब आप 3 महीने आप ये करते रहो, then you, so make goals short term for people. If you give them short term goals कि आप ये 10 दिन करो, फिर आपको ये difference, then people like to do.
One more thing. Usually, patients like follow very strictly the medication, but not diet. So, how we can resolve this problem as a dietitian?
Yeah, that of course, you have to counsel the patient one to one because, like I said, that they don't see the effect quickly in terms of drugs. So if you tell them 100 things to do in a day in terms of ये डाइट में आप ये भी बदलिए वो भी बदलिए सब कुछ बदल दीजिए टॉपसी टर्वी कर that nobody likes. So give them one small change and that small change should be one that they can easily follow. अगर आप सुबह उठ के प्लेन ग्लास ऑफ वाटर लेते हैं तो उसकी जगह एक आप फर्मेंटेड ये वाला ड्रिंक that they might be able to do. But अब से आप रोटी बंद कर दीजिए मिलेट खा लीजिए और इस समय ये बंद कर दीजिए ये खा लीजिए that they, so don't overburden them when you're counseling. Don't overburden. ठीक है?
Thank you, ma'am.
Okay.
Good afternoon, ma'am. Ma'am, like nowadays the research on millets has been like very growing area. So, like rather than educating people, what would you suggest to do other step?
You mean not to educate them?
No, not to. I'm not saying not to educate. Like the research on millet is like increasing, widely increasing.
Used in these last last times, especially in my context of Europe, but I believe also not only in Europe, also worldwide. Then I will also ask you about your knowledge and your trends of consumption of these particular sweeteners or even others you have here. First, I would like to highlight the erythritol. This is a natural sweetener, and the industrial production of erythritol has gained prominence with the rapid development of electrochemical processes. So during these processes, or this process, the erythritrols and the erythritol are produced by the electrolytic decarboxylation of arabinoic and ribonic acid. These substrates are the substrates for the reaction and are obtained by the carboxylation of the sugars with six carbons. So it's not. Now I think yes. It's fine. However, a more natural method involves the biotechnology process, which results in higher yields from fermenting a sugar source. So, erythritol derives from fermentation processes conducted mostly by fungi or other synthesized lactic acid bacteria. To produce this erythritol, the common pathways among yeast-like fungi genera include these that are mentioned here: the Trigonopsis, Candida, Pichia, Moniliella, Yaria, Pseudozima, Trichoposonoides, Arabinidium, and Trichoderma. This is the main genre of fungi that common pathways in order to produce this natural sweetener. Regarding the industrial production proposes that this specific species of Iarea politica, Moniliella pollinis, and Trichoponoides meganicis are reported as the most effective amongst all we have mentioned before. So one main part of the production of this process involves the separation and purification steps. Once they are very crucial when the erythritol is used and is taken as a food additive with the function of getting our foods sweetened. A patent describes that to recover this erythritol from the culture medium, separation from fermenting microorganisms is a requirement. So it is followed by an ion change chromatography and crystallization. Moreover, the chromatographic separation step was subject to activated carbon treatment to recover this fraction of erythritol. And as we can see, it has this similar, let's see, in the right corner of the slide you can see it is aspect we can only by view we can finding similar to other sweeteners, to other sugars, and it can be used in that form to give some sweetened power to our foods. Another one, it is tagatose, another natural sweetener, and the biotechnological tagatose production, it is mainly by enzymatic isomerization that is a preferred alternative to chemical processes. And for the biological D-tagatose manufacturing, there are several biocatalyst sources that can be resorted. For example, the L-arabinose isomerase that we can abbreviate by AI, which can catalyze the conversion of this D-galactose into D-tagatose and converting also L-arabinose into L-ribulose. This is regarding and due to the similar configurations of their substrates. Yet the biological D-tagatose production is not very common, is limited, and given the lower bioconversion efficiency of this LIA, a metal ion requirement, and the poor thermostability and low affinity of this enzyme for the D-galactose. It has thus been suggested that applying the protein engineering and genomic tools may enhance this bioconversion efficiency for the tagatose production by amending the functional properties of L-arabinose. So, applying high throughput screening for a selection method helps to evaluate individual protein variants and hence increase the possibility of screening specific mutants with greater catalytic activity. During this D-tagatose production, the safety problem caused by the enzyme or cells have not generally recognized as safe, also called as GRAS hosts, can be overcome by transferring the gene of L-arabinose isomerase to the generally recognized as safe hosts like C-glutamining and Coronium bacterium, among genus, and this Bacillus megatherium. Ultimately, more research needs to be conducted to explore new sources of biocatalytics from these generally recognized as food microorganisms apart from the enzyme secretion and expression in the food grain microbial host. This is very important when we are talking about all of these, we can say new natural sweeteners that people are more not so accustomed to include them in their diet, because it is important to research and to assure that no harmful is posed in question regarding the health of the consumers, and a lot of research is needed to do also regarding this. Here another, and perhaps the most well recognized between all of us, the stevia glycosides. And these stevia glycosides have been used, I think, also here, also over the world, have been widely used as like supercritical fluids, also ultrasonic waves and microwaving. Besides, the multi-stage membrane process, which has been developed to concentrate these glycoside sweeteners, is also mentioned and highlighted with the bitter tasting components from the sweetener concentrate being washed down during the nanofiltration. And sometimes when this bitter, a kind of bitter flavor, bitter taste at the end, and people can identify some different flavor, a different taste when adding this final product to their foods, and this can be in some way one reason of it is not so well accepted. This can happen also with other cases of other sweeteners, very common when they extracted from plants. The convention extraction process described in the studies often follows similar methodology, whereby stevia leaves are extracted with hot water and alcohols. In some cases, the leaves are pre-treated with non-polar solvents, and to eliminate this is to eliminate fats, lipids, essential oils, and chlorophyll and other non-polar substances. With this pretreatment, the extracts are purified by precipitation with either salt or alkaline solutions, and then finally concentrated and redissolved in methanol for the crystallization of the glycosides. Another natural sweetener that I would like to discuss is the glycyrrhizin. The glycyrrhizin is also extracted from plants, and the methods followed to prepare this glycyrrhizic acid from the licorice roots have been investigated by several researchers in the last few years. And what is reported in the literature that the number of procedures as regards solvent extraction by various organic solvents, purification by ion exchange and polymeric resins, chromatography separation, sorption, foam separation, supercritical fluid extraction. So all these methods, the microwave assisted extraction, all these methods can be used to make the extraction of this glyceric acid from the plants, from the roots, the licorice roots of the plants. And most of this existing process that function to extract and purify the sweet ingredients from the licorice roots, that is what we want, involve several steps and large quantities of solvents and chemicals. So, extracting this glyceric acid from the roots includes extraction with hot water and ambient pressure in the presence of a number of additives, chemical additives such as alkalis as well, mineral acids, ethyl alcohol like aqueous ammonia, methanol, ethanol, which are the most well accepted technologies at nowadays, so at the current knowledge. And the primary aqueous extracts from the licorice roots contain this licorice acid and, of course, many other substances that are soluble in water, in aqueous medium. So, which are then subjected to further process with the main goal of obtaining a more purified product. So, this pure glyceric acid is also prepared from these roots using alcohol as the extraction solvent and in an ultrasonic device followed by purification. That is another option, of course, with different costs. And we can say that the conventional solvent extraction technique followed to extract this glyceric acid from the licorice offers several disadvantages, namely, consider the solvent requirements that you need to add to make this extraction. And the extraction time can be also quite long, lower yields and higher extraction temperature. So all this requires developing an effective economic extraction method. And the purification procedure involves the acidification of the extract by the addition of some acids, and of course we can have some drawbacks related to it. The ultrasound ultrasound assisted extraction has shown that the extraction rate rises due to the cavitation, because the developed cavity grows in size and then abruptly collapses with the release of energy at enormous rate, which thus increases the local temperature and pressure. Therefore, greater solvent penetration in cellular materials take place, which improve the cell content release in a bulk medium. Another one, the thaumatin, perhaps better known than glyceric acid or glycyrrhizin, but not so well known, I think, that, for example, the stevia glycosides. And this thaumatin production process can be strongly affected depending on the quality and availability of the source materials. In order to achieve a stable protein production that meets its demand, a series of studies were conducted involving these thaumatin productions with genetically engineered microorganisms and transgenic plants. Although using a plant system offers some advantage over macro systems in terms of its scalability, safety, and economy, they still lack some benefits that can be obtained from macro hosts, such as the possibility of controlling growth conditions and product consistencies from batch to batch. The micro biochemical production methods have been considered for this production because this protein is normally too expensive, and the recommended DNA technology be applied to produce sweet proteins in host microorganisms. And the most promising host known is this yeast, Pichia pastoris, that has a tight regulated methanol-induced promoter that well controls recombinant protein production. And despite thaumatin have been studied for a long time and for several groups of investigation, in the last 30 years there is still much to do, especially regarding the production to be considered cost effectively, and we can say it is can be considered a very interesting option and to stimulate their daily use by the populations. Some other natural sweeteners that we can find in our lands, maybe, and perhaps more well known. Though you have here some sweeteners that have been described as ever friendly regarding their production methods, and that are becoming very popular worldwide. And these food ingredients can be considered also for health conscious consumers. And I would like then, of course, to see if you agree with this. If you have some other sweeteners, for sure you have in your country, in the regions where you live. But I would like to also mention these five. One is the honey, the raw honey. I believe all of you know, one of the oldest natural sweeteners. This honey is a sweetener than sugar, and is the only sweetener obtained from an animal source, in this case insect bees, and is a sugar secretion that is deposited in the honeycombs by bees, the species Apis mellifera, also indica, the well-known rock bee, among other species of these genus. We have the blackstrap molasses, the byproduct from raw sugar refinery or sugar cane factory, that it is thick, dark, viscous liquid that is left after the final sugar crystallization stage, from which no more sugar can be crystallized and economically used by usual methods. You have the maple syrup, we have talked about it, that is made from the sap exuded from the stems of the genus Acer. Usually in spring, it is particular from this season of the year. The sap primarily contains water and sucrose with varying amounts of amino and organic acids and phenolic substance, which is concentrated by heating to produce a wide range of flavor compounds. Then we have also the coconut sugar, very used in some particular countries, I would say, especially in the African country, in the African continent. It is locally produced from the fluent sap of the coconut tree and the coconut palm tree, blossom, and the juice collectors climb upon trees and cut off and open inflorescences with stickles, and the escaping sap is then collected in bamboo or plastic containers for 8 to 12 hours. And the lime is sometimes added to prevent sap from fermenting. Of course, this has different costs. We can all imagine different production costs, for example, when comparison to the sugar cane or white sugar. We are more accustomed, and if we study a little bit or learn a little bit about the production methods for these alternatives, we can see the justification why when they arrived in reassurance cannot rule out the need to conduct detailed scientific studies to prove the safety of the natural compounds to be used as food additives. And sorry, one example of that is the sweeteners that we have been discussing here. The food industry needs to face the challenge of developing new products with natural functional sweeteners to continue innovating and satisfying consumers that want all in one, as I mentioned earlier. Of course, a safe product, otherwise you can put it on the market. A tasteful product that we can enjoy it when we are consuming or when we are adding this particular sweetness to another food, and that is plenty of health benefits, health impacts, and as functional properties. So this is what the consumer demands, and of course, this is not easy, not always possible to accomplish with all these requirements, and sometimes the label of being natural, it is not the same that we go exactly to the nature and put it on the table. So as we see here, there are in some cases some extraction methods, and we need to add some other components, and the chain is quite long until we have the final product, and of course that will vary the characteristics of that product in so many aspects, and the price also, the price I forgot, but of course the price is also that the consumer wants to pay the less as possible. And this, of course, poses a very big challenge on the food industry, and also on the health professionals and all of us to find this miraculous component or components that we can recommend to our populations. So let me know what sweeteners I haven't talked here, and you have in your regions, in your country, and we are not specified here. And of course, you also use it as to sweet the drinks, the dishes, apart of the sugar cane and the white sugar. Thank you.
Good evening, sir.
Good afternoon, good evening.
So, how do cost and benefits of natural sweetener production compare with traditional sugar, considering health, ecological, and market criteria?
Yes, most of them are not, as we see here in some examples. Some of them, the production costs are not so interesting. That is one of the great challenges, and I think you can see it when you go to the market. That these options are not are not so cheap or so interesting from that point of view for the final consumer, and the reasons are related with various aspects. One of them are not local. For example, I have maple syrup. I have agave. I didn't talk about it, but I have agave syrup. I have some options that you have not in Europe, not neither in Portugal. So the whole way it came from their natural origin, it has costs, and then the extraction methods and the processing. For example, to collect the licorice, from the sap, from the coconuts, then wait 8, 12 hours to ferment, all of that, it's time consuming, not time consuming, but efforts from those ones who make this work. This will be reflected, of course, in the final price. So if you have a product that its processing of the methylene line in their extraction are different compared with the other ones we have at lower prices, and a part of that they are coming from another continent. It is difficult to find here some strategy to become more interesting from the point of view of economic view. Of course, that is one of the challenges.
Yes, sir. So one more question. What role should consumer education and labeling play in scaling sustainable and healthy sweetener use?
You are asking what can we
What role should consumer education and labeling play in scaling sustainable and healthy sweetener use?
Yes, regarding sweetener, the education is very important, and at the early stage is not to find alternative sweeteners, but to introduce the less sweetener as possible, because some foods they are already sweet. So, for example, you have in some parents that have the custom to add sugar, white sugar, but it could be another one to the fruit to make the children prefer or eat easily the fruit, because otherwise they cannot like too much, especially of course compared with other kind of sweets. So to have this role easier, the parents simply add sugar, and mainly white sugar, and of course this is not good. If there would be some actions or some education regarding to this since the early ages, of course, not be adding sugar to the fruit, because fruit has already its own sugar, so you don't eat to add, and then it's the habits, the routine that those children will take to the adolescence, to the adulthood, and it's very complicated to change the habits. Here, the sugar is very similar to the salt. When you are accustomed to add one amount of salt and the sugar as well, since very early ages to everything or to the most of your dishes, it's very complicated from one day to another to substitute for another thing, or you find another thing that is quite similar, but then we have some differences, and the price is very different, and this is a very important point. Not only the difference from the point of view of the taste that some of these products have, but also the price is very higher when compared to the white sugar. But it's very complicated when you are in the adulthood. When you since children you were accustomed, you learned to introduce sugar in the fruit, or to you are accustomed to intake some high amounts of sugar or salt. You can talk for both. You are talking about sweeteners, but the habits and the education regarding the salt consumption is quite similar. Is quite similar. These alternatives can be, of course, all of these alternatives have we already discussed in the other session. All of them seem, since they are generally recognized as safe. Of course, that is very important. They seem better than the refined sugar, than the white sugar, because on the white sugar you have only sugar with rapid absorption sugars, with nothing else. You don't have amino acids, you don't have polyphenols and other elements with functional activities that you find here. But here you have also calories, you have also sugar, so it is not the same. You can consume this. This is wonderful at your own way, with not any concern about the amount or the quantity you will consume. No, of course, take care. It's the same as the fruits. You have calories in fruit. You have fructose in fruit. You have sugar in fruit. So, of course, you have to pay attention also to that. It is very important.
Thank you, sir.
Thank you.
So good evening, sir. So like you were saying, here in India we get raw honey, but it's almost adulterated. we get this.
Yes, yes, that is an important issue also. And once again, first of all, the food safety and the safety regarding the product. And honey is also one problem, not only here but in other places that we can have that kind of adulteration. So it's very important to control that. Yes, yes. Thank you for your appointment.
And so we get molasses, this black salt molasses.
You have also.
Yes, sir. And coconut sugar is not available in the north part, but probably it's available in the southern India. But it's not very common. Stevia is available in
And the
all.
prices are higher than the other alternatives, or not so much? The coconut sugar.
That I don't know.
For example, you have coconut sugar in Portugal, but not locally, of course, and it's very high. It's very the prices are very higher compared with sugar, with white sugar.
So here it would be higher. In Delhi side, it would be higher because they'd have to get it.
Oh yes, yes, for sure. Yes, that we are talking about. Yes.
But stevia is available freely in the supermarkets. So, but its taste is not acceptable to many.
Yes, yes, another problem. The taste, yes, is different.
So my question is, when so many studies have been done about this risk of this sugar, like high fructose corn syrup is used a lot in US, I'm told. And you mentioned aspartame. When we know this risk, why don't we phase them out and use these alternatives? Or will it help to mix that refined sugar with these kind of alternatives? How will it?
How can we make the people use more these alternatives and not the refined sugar? There are two main reasons: prices that have the ended product and the taste. Because all of these alternatives, it will imply a different taste, and perhaps some people that is not a problem can accept or can even enjoy. But the price is for the most. If you think in the global population, the price is quite higher, especially in the places in the regions that you don't have local production of that, and you need to import. For example, in Portugal, we have to import this: the coconut sugar, the maple, the stevia. The stevia is also very interesting and very marketed. Maybe I can say, at least in Europe, we found very products with stevia, but when you see the price, it's not for all. At least to consuming that on a regular basis as they usually consume sugar. We can, of course, one time we can buy some product with stevia or that alternative, but not to substitute as on frequently consumed, because the price is quite different. So for the population, the reason, I believe the main reason, and of course they are not so access in the markets as the white sugar. White sugar, you have it in every place, and some of these alternatives only on some specific shops, some specific markets, because the price is high and nobody, not every shops wants to have it because they know that they will not sell. So only on some particular markets, shops you can find. So the two main reasons, I would say, price and taste.
Thank you, sir.
Good evening, sir.
Good evening.
So, sir, my question is, can this erythritol be used in the production of bakery products?
Yes, if it will be accepted. Erythritol is also a very strong, a very different taste. But from the point of view of theoretic point of view, yes, it can be used. The other thing is if then the final product will be accepted by the consumer. That is that will be always unrelated, not only specific to racial, but all of this. It's like the stevia. The use of stevia, it can be used, but the flavor, it will be quite different if you use stevia, erythritol, or white sugar.
Okay. So, sir, can it affect the texture and shelf life of this bakery product?
Yes, you can have them also from the texture. Yes. The organoleptic characteristics may vary, and according the sweetener you use may vary. And the same we have if you make the same experience with the artificial ones. You can try to make a cake without sugar cane, and use it some artificial sweetener, for example, the aspartame. We will see the flavor, the taste, very different, very different.
Thank you, sir. Good evening, sir. So my question is that how uh, how natural sweeteners can interact with cut microbe?
It's a very interesting question, and also not only the natural. We can talk about artificial sweeteners, and that is a very hot topic, an emergent issue of research. And for example, one of the concerns first regarding the artificial sweeteners there is they are considered as safe in some limits, in some amounts, but some researchers are studying the impact that those sweeteners can have on the metabolism of the microbiota we have in our gut, and then of course indirectly that if the homeostasis of that microbiota is affected, of course that can affect our health, our gut health, and our health. The same with this, of course, need to be studied, in particular, in case by case. And for example, talmatine is studied, and that can have some affections. And there is no much evidence on that, but there is effect. We know that it will affect, of course, the gut microbiota, and consequently our health. And this is a very interesting topic to study. Yes.
Thank you, sir.
Good afternoon, sir.
Good afternoon.
So, I don't remember the exact name, but one of your slide, like in table, you were mentioning, I think, tomatin or glyceric acid, like it's reducing sugar after meal. So, postprandial sugar, it's reducing. It helps to reduce it. So, can you explain, it's a natural sweetener. So, how does it does?
Yes, but it's a sweetener. It's called sweetener because it has the power of make when you add to that food sweetener. But the difference between these sweeteners and the refined sugar, perhaps the most non-sweetener we are accustomed to, is they have another elements, and these elements can help in that way. And that is an example of glyceric acid, glycerin, that have some elements, bioactive components that can make the digestion slower and can act also as that. But of course, this we need to study in which kind of consumption on a regular basis, in which amounts. All of this is not so well and so specified in the literature. They have these components, they have these bioactivities, the white sugar doesn't have. So this can be interesting, but at which point? The quantities that we will need to add to the food and we will intake are sufficient to see all of this. Because also when I present the table with all properties that say anti-carcinogenic, anti-mutagenic, this need to be studied. We can only just see the macros, the food macros, and the components we find there, and see this is wonderful for this, for another. No, but in which amounts you will intake this, you will eat this. And then, if included in the diet, you will not consume this alone, and with the other components. So all of these need to be studied.
Okay.
Good afternoon, sir. Sir, how do natural sugar sweetener affect the metabolism in compared to refined sugar?
Exactly the same answer I gave to your colleague. The reason is exactly the same.
Okay, sir.
Exactly the same.
Actually, I did not listen.
Nothing to add.
Can you explain once more?
Ask your colleague to explain.
Okay, sir.
How
Thank you.
can? No, please ask. I want to know if she
Like,
make this a bit more interactive.
first of all, so that it's it has not been studied. And also like to know that what metabolic process is going on, we need a case study and what and all internal due to which process, or like maybe it is like lowering sudden glucose spike of other food which has been eaten by the person, maybe like that.
Yes, we have to see the components that are in that specific natural sweetener we are talking about, and then not only the components, we have to see the interaction of those components in the organism, in this case, in our organism, in our metabolism, and included in not alone, but joining with the other elements of the diet, and which quantity of natural sweetener we are talking about. It is not only to see they have polyphenols, phytochemicals. No, but in that amount, with the other components, this will really have that carcinogenic effect. We don't know. I don't know the quantities. And of course, we don't know if it is feasible for the people to consume it. Because with these prices, populations can't consume. So it is impossible, it is not worth to being studying something that population can't buy. We are studying that for what? If we can't find a way to make it more accessible, more available to the population. That is also so important, so more important than studying all the bioactivities, all the properties of the food. If I have sugar cane, 1 kg for less than €1, if I have 200 grams of agave syrup for €10, I can say stop consuming white sugar and start to consume agave syrup or maple syrup or coconut sugar or what else. Wasting time on studying the properties and money. Because when you talk about alternative, it must be a suitable alternative, a feasible alternative. So the price matters. We must think on production methods and where we will collect those sources, alternative sources, to recommend them to the populations. I can recommend the populations to consume something that they can't access. Once again, the availability and access. The product must be available, but not access to all the people. And I want to talk, and I want to point to the general population. But of course, that will depend each source, each natural sweetener, and it will depend of the region. Because in some regions, some sweeteners, some product can be high cost, but not in the others. We have to see all those aspects. Yes, thank you.
Sir, why solvent-free extraction is vital for sustainability?
Which extraction?
Solvent-free
Yes.
extraction method
Yes, of
is
course.
vital for sustainability.
And of course, for example, when we are talking about some of these specific sweeteners that you need to add a lot of chemicals, and the extraction process takes a longer time, you have this and sustainability are not in are not related. So this is one example of why when we are talking about natural products, they can make the direct relation. It is natural, so it is very sustainable. So I think here the example of this cannot be true in some cases. So if we add that, we need to add all of that solvents and then to make the separation, the purification, all of that. How long we will take and how is the way we need to do to until we have the final product. Of course, the source is natural, but what we need to do and time consuming and money and everything to arrive to the ended product. So where is here the sustainability? And if I don't have that product in my region, in my country, in my continent, and I have to buy it from the other part of the world. So if we analyze this, we can have a natural natural product, natural food product, but of course, sustainability can be compromised. And that is one important thing, not to be natural, that is for sure a sustainable one. Thank you for your point. Yes, thank you.
So thank you so much, Dr. Rapsu, for that enlightening and detailed presentation. Your talk beautifully highlighted how natural sweeteners can contribute to a healthier and more sustainable food system when produced safely and responsibly. You took us through the fascinating process behind the production of sweeteners, natural sweeteners basically, and how biotechnology is helping when produced. Uh, these processes are more efficient and eco-friendly. It was particularly enlightful to understand that while those compounds come from the natural sources, their safety, purity, and scientific validation remain equally important. Your emphasis on the needs for continued innovation in the food industry to develop natural functional sweeteners truly tied the session together. Thank you once again, sir. So, as we come to the close of this day 7 of the GIAN program, it's wonderful to take back one another enriching day of learning exchange. Today truly showcased how innovation and tradition come together to shape the sustainable food future. For exploring bioprinting and futuristic food production technologies, to discovering the power of millets for nutrition, resilience, and understanding the potential of natural sweeteners as healthier and eco-friendly alternatives. The day offered a perfect balance of science, sustainability, and real-world relevance. Each session encouraged us to think beyond the ordinary, to imagine the food systems that are technologically advanced, nutritionally rich, and environmentally responsible. The discussions are also highlighted the importance of the collaborations across disciplines to bring about meaningful changes in the food and nutrition landscape. I sincerely thank all our distinguished speakers for their enlightening sessions and also participants for their enthusiastic engagement throughout the day. Before we conclude, a gentle reminder for you guys, please be prepared for the GIAN assessment scheduled maybe tomorrow or day after tomorrow. It will be help all that we have learned during the intensive and inspiring week. With that, we officially conclude day 7 of the GIAN course. Thank you all for your active participation and see you tomorrow for the assessment and another fulfilling day of learning. Have a pleasant evening. Thank you so much, guys.